And then that's going to start up in just a second. And then we'll be live. What's up, Walrus? How you doing? I got a lot of chips, and so we're going to try to breadboard some of these. Should be pretty cool. How's everybody doing? Welcome, YouTube, to the stream. I don't get this. Why is he just talking at us? This isn't a tutorial. What is this? I mean, I will explain what I do, hopefully better than other people do. We're still in just chatting. I guess we're just chatting. I mourn my science and technology category, but there's freaking nobody there. So in terms of like my channel growing, it's not going to happen in there. So we've gone to just chatting. Poopsie Doodle had a good point of going over to programming, software, and game development too. When we do that. So I took a machinist job this morning. I don't know a lot, but I've done it. I'm nervous. Hey, that's awesome. Hopefully you can find somebody that'll show you the way, because a lot of that trade stuff, that sort of machinist stuff is handed down. It's knowledge that's passed down from person to person. So there's a lot to learn when you get there. And I don't think anybody's expecting you to not be green. So just be safe. That's all you got to do. It's easy, right? That sounds awesome, though. It sounds like a lot of fun. I should have been a machinist. I went to circuit school instead of end mill school, or whatever you want to call it. I'm really miffed about this battery. It's not enough current to run this thing, and I've gotten under the hood a little bit on the WLED code, just to keep you guys caught up. I've been looking in Platform IO. I don't love it, but it's what it's. And I've been looking into all of the underlying stuff that makes this, makes this stuff work. It's complicated. I don't understand half of it, but I did find some parts of the code that relate to the buttons. And there's apparently Short Lurker found this because I was talking to him on the Discord. Short Lurker kind of butt in and gave me the rundown. And apparently other people have had this problem. The WLED people, or whoever coded WLED, doesn't understand that the button stuff is a complete mess. I think maybe they just don't think about the common applications that might happen with their code. And for me, our code is trying to be as energy efficient as possible because our battery is tiny, which is pushing the limits of the code, and it should absolutely be something that the software thinks about. But there are these like recovery modes and stuff that are in here for people who don't know how to like base level flash a microcontroller. It's for, it doesn't need to be put in there for the hardcore people, but there's some ways that the program is organized that don't lend really well to our customization of it, and they don't see any reason for it to exist in any other way. I am probably going to make some alterations that are deep in the code that would allow for that sort of scalability out of the thing. Have if-defs at the beginning of the program that look to see if certain things have been identified in the override platform IO thing, which is unfortunate because it won't get incorporated into the main code. And so if I decide to upgrade my code to a later version, I will have to move my own edits over, which is probably something that GitHub could facilitate. And I just don't know GitHub enough to do that. So I'm gonna get my filthy fingies inside of this code and make it so that it shuts down the wireless stuff on initial boot, and so it's in a low current mode. The off button is being hindered by the push and hold modes that exist within this code. It's very sloppily done for a singular button interface. And it's different for the ESP32 than it is for the 8266. So there's like weird things that I got to figure out on this thing. But I think with just like a base level edit, I'm just going to keep it simple and not try to make professional edits to this. I'm not refactoring their code, and I think that'll be the least amount of work. But in the end, how many milliamps is this thing going to be taking up? Mainly, I need to choose playlist items like this, where it just barely uses the LEDs, but I always need some LEDs to be on. So I'll need to figure out what my playlist is going to look like. That's going to be a lot of work. And then try to keep it as low current as possible. And perhaps I need to 3D print a new enclosure in order to facilitate a larger battery if it's going to be this big of a problem. It'll work for like an hour though. And this is like really cool what it's doing right now. And if I just find presets that are just kind of pretty cool, that could be fine, you know? Because as she runs around and barks, bark, bark, she is scared because I was getting ice out of the freezer and I was handing her a piece of ice to chew on, and I dropped my glass and ice shot out everywhere and made a big noise. And so she kind of got away, looked back at me, and I said, "It's all right, Bubby, you don't have to be scared." And then she just went, "No, I'm out," and just went upstairs to my room where she is asleep. She's just taking a nap upstairs. It's very windy out today, so I don't know if she likes that at all. But my window, I keep the window on the second floor cracked just a little bit so she can hear out and I get fresh air. My poor petrified corgi, absolutely nowhere to go. What's this song? I wonder how one row of LEDs will do in the collar. You know, if we light these up, what that'll look like. Because I don't think it'll have that much to do dynamically. It won't, because this has the 2 rows. It really does a lot more. It really does a lot more. It's very cool. It's quite cool. Oh, the Raspberry Pi 5. I got a lot of work to do on that. Hey, what's up, Deano? Got a lot of work to do on the Raspberry Pi 5 to try to get stuff rolling on this. I'll have to get into that because that's going to kick off more work on Burn the Subs, which is a project that I theoretically have and have done work. What did this just get stuck? That I've done work on. Did you guys know that I used to have a big board in my shop that burns the names of subscribers onto itself? Did you know that? Did you know that that existed? I need to save this end cap here in case I want to waterproof the LED strips. That goes over there. All right, let's see here. I got like an hour of sleep last night. I'm not in good shape today, but we'll soldier on. We'll get some stuff done here. I'm gonna make room for synth stuff because I wanna try that Moritz Klein drum sequencer. It's part of the Erica Synth's simple drum machine, and these are 7400 series Logic chips. Not just Logic. It's all the sort of operations that 7400 series chips do. They're kind of a one size meets all computing solution without using software for microcontrollers. That's how we did stuff. Microcontrollers bring into them a sequence of events and can replace a lot of the sort of logical elements that these chips do, but these chips do some pretty cool stuff. We donated the board to a local hospital, yeah. Poopy McFart Pants. Mommy, who's Poopy McFart Pants? Who's... I'm not even gonna say it. Some of the names I just can't even repeat in polite company. I just can't. Scandalous. They're horrible, horrible, horrid, awful names. And they're Twitch accounts. They're all Twitch accounts. The vice president mentioned a Twitch streamer. What a time to be alive. Is that gonna bring people in? Probably not, no. I don't think so. Yeah, the adult film stars, edgy usernames, just all kind. There's like several celebrity names that probably weren't the actual celebrity account. I feel neon. Ooh, meow, 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 meow. So this year for Halloween, I am actually dressing up as an actually decent person. And I am pretending that I am one. It's a very funny costume. Funny to pretend to be somebody who has empathy these days, right? It's a very unique costume. Nobody's really dressing up like that. I don't think we need shrink wrap right now. I'm gonna push this to the end there so that there's something that reacts to my voice and the farts and stuff. Oh, you're in the city the song was recorded and performed in. Nice. I assumed it was just like San Francisco or something, right? California somewhere. That's where I assume everything gets made. Who are a San Francisco-based music collective? Definitely need the resistors. I'll need more jumper wires. Hookup wire I don't really need. Ah, avalanche. Ah, my status light. No. I still have to make sure that this thing works by actually going into the server and clearing the messages that are making this purple. I can't trust that it'll turn red until I make it turn off, until I make it not purple. It should go green when I've addressed all of the warnings that are on the server right now. Maybe we could do that like right now. Cheap viewers. Oh, sweet. Hold on. Let's. Oh shit. I'm glad you're here. Oh, I have to pull YouTube up. I have to pull the YouTube chat up. Sorry, YouTube chatters. Let's go ahead and just like hit you with that. My alcohol making stuff is annoying. I think it would have been easier if I made a gallon of cider instead of a quart. All the measurements online are based off gallons. Well, so around here, what I can do is I can jump over to the local Acme food store. It's actually called Acme. It's called Acme. It's a supermarket in America. And they have local Pennsylvania cider for like $5. On Tuesday, this computer like majorly shit the bed. And so I had to get that back up and running. And then Thursday's stream was stopped because we had a huge storm roll through here, and having purchased a generator for the house, it automatically should come on and make everything work perfectly fine, but the internet was flaky because of the power issues. Because I don't have control of the substation, I can't put a battery backup on it. So while we had power, we didn't have good internet, reliable internet. And in fact, just when I was typing that up in the Discord, we had a brownout. So this is last week. So this is the one that I can get rid of. And this one is the new chat. There we go. Now we got YouTube chat up. This thing is real convenient. The Social Stream Ninja app. I know it's probably running Chromium, so it's like I haven't actually been able to get rid of Chrome on this computer. But it is nice to be able to just one click get YouTube chat up. Since I have fiber, in theory, as long as my modem has power, I should have internet if there's a power outage. I realize that light and electricity, though, you know, bedfellows are totally different, and you don't need electricity to make light. You need electricity on the receiving end of what you're sending your light to. So whatever power station exists, whatever internet station exists in the infrastructure also needs to get power. And yes, it should have some kind of a backup on it, but the power goes out, the lights switch over on the batteries, and then a minute or two later, the internet goes, and that's it. So we at least have power, but we don't have great, we don't have the ability to communicate outward. Veet Nukem, sub for the Prime for 44 months. 43 months ago, I got burned on the BTS for the first time. First and only time. Okay, it works. And having status lights and Node-RED and all that stuff has been working towards building up Burn the Subs. I'm thinking of the whole project at once, right? Took the whole thing down, reinvented some of the ways things work. We're going to be using bump stops instead of switches. That way nothing can wander around, so it'll go and it'll hit a bump stop that is like well and truly bolted down so that it won't move at all. Creme de la chrome, chrome de la chrome, chrome de la chrome, chromium, yum chrome. If it ain't make you go faster, cover it in chrome. Yeah, so my simple cider recipe is, that's it. That's all there is to it. There's no effort. Zero effort is where it's at. And it makes a pretty good cider too. Maybe I should get into my NAS right now and do some of that. 192.168.2. What was it again? It was 220. Oh yeah, not logged in. One of these days, I'm going to have this camera over here on the keyboard when I type in a password, and that'll be it. I will then cease to exist. I'll out of existence. There'll be a little puff of smoke where I was. Why aren't you logging me in? Is it? No, I got that right. Hold on. Don't tell me I changed it. No, I had the least secure password in the world. It's probably all, yeah. Oh, no, I know what it is. That's right. Throws me off. It's one of the only ones that has a, okay. There we go. Never save passwords, Firefox. It's your problem. Theoretically, if I clear these alerts, well, what if I dismiss them? Oh, this is yeah. Dismiss everyone. Pool is consuming you. Yeah, we close that one. System update, close that one. So theoretically, in like a minute, this should go green, even though I do have a couple alerts that are unaddressed. Because it is just getting this list. It just gets this list of alerts. I think it might see these, though. It might get those. I'm not sure. When it's just apple juice from frozen apple juice concentrate. Oh, apple juice. Okay, that's an idea. The cider here is like rough. It's it's like brown and not transparent, which is why I like it. That's why it's really good to brew it. And then once it's done brewing, I'll put the cider in the corny keg and refrigerate it with, I think, 26 PSI. I think it's 26. And then the CO2 will get into the liquid and carbonate it. And then I have a carbonated hard cider that's really, really good. It's very bitter. Bitter and very little sugar, and I like it a lot. There's a big chart for PSI versus carbonation volume. Not volume, but just carbonation. PSI per carbonation. I don't know how much soldering we're going to do today, but we are going to use some LEDs. Why are you... Everything's trapped. It's all wrapped up in each other. Fine, whatever. Push out this way a little bit more. Oh, is this that party song that just goes ree? That or it wants to be that song. What, a Daft Punk song? Maybe. Maybe. Perhaps. Perhaps. I've only done natural fermentation. Forcing it in sounds nice. Wait. Let us remember context. Yeah, so the champagne yeast is kind of a bitter, dry yeast because it makes so much alcohol. It gets rid of all of those... Oh, yeah. So at the end of the brew cycle, when the yeast has done all its job, what you can typically do if you don't have the corny keg and the CO2 and all that stuff, because, that stuff costs a bit of money. It's good to have, though. It's nice to be able to drink it like a day later. But at the end of the brew, what is typical of home brewing is you would add a little bit of sugar, like powdered sugar, some really nice sugary sugar that's very pure and doesn't have bacteria all over it. You add it back in, and then the remaining yeast, the survivors, the really scrappy yeast that's barely remaining alive in your brew, will then continue to produce CO2, and if you top it off, it'll create a bunch of pressure, and the CO2 that they're excreting then gets into your stuff. So it takes like a couple days. It takes like a week, I think, for it to naturally carbonate itself. When you do it with the CO2 bottle, it takes like overnight. We'll get that in there. So you can put it in the fridge, carbonate it in a day, and then I have a tap that I can hook it up to and immediately drink it from there. Or you can then use the corny keg with a bottling setup that I have, and the bottling setup allows you to put equal pressure and transfer one over to the other cleanly, so that it doesn't get all over the place, and then you cap it and it goes in the fridge, and then you got your carbonated beverage in a bottle. I don't do the bottling part. Takes time. I have a bunch of bottles that I need to go through. I'll do that when I feel particularly generous to my friends, because then I'll start just handing out bottles of delicious stuff. I should bottle cider and get that out to my friends, because it's so easy. It's so easy. Supermarket, 25 bucks, dump it into Carboy, dump the yeast in, cap it, bubbles for 3 weeks, I don't know. Put it in the corny keg, CO2 in one night, drink a little bit, bottle the rest, give it out to people. And they're like eternally thankful. It's like manna from the gods. It's like, oh my God, that's so nice. I can't believe you would give me stuff. Oh. And you're like, I'm a callous and unfriendly person. Don't give me credit. The string of white LEDs that I'm just not going to do anything with, because this is the OG dog collar lighting. Not as cool as this. Bump, 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 bump. Look at all these chips. I got chips for days. For days and days. I got all the chips in the world. Dun, dun, da, 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 dun, da, 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 da. It's like a Factorio asteroid. All these things that do things. It's crazy what you can come up with logic. Like, I think in microcontrollers. I don't think in 7400 series logic, so it's unique to me that you would be able to put together a drum sequencer out of this stuff. And you just use flip-flops to carry over bits. This has not changed color. This is worrying me. Happy Halloween. Hope you're having a good one. Yeah, I like to keep it quiet on Halloween unless I'm doing something crazy. And I'm not doing anything crazy this year. Used to go to some pretty big Halloween parties around Philly. They were fun, but it took a lot of effort on my part to make a costume, because I'd always hold myself to a high regard. I would hold myself to high standards for my Halloween costume. So it would typically overwhelm, and then I would have nothing for actual Halloween. Let's see, where are we going? Framed chat. I'll move you guys out and forward a little bit. That's better. Kind of a 1, 2, 3 thing going on there. There we are. And oh no, there's going to be a whole 16 bars, isn't it? It's going to drop. It's going to drop hard, but it's not going to drop immediately. It's going to hold off as long as possible. Oh no, never mind. It just dropped. Oh, there it is. It dropped. It dropped. Yeah, yesterday was crazy. I felt like I was playing hooky, not streaming. Just because, I felt like I was lying about stuff. And then in the middle of the day, the electricity is like, blah, 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 blah. So I didn't want to have like a 26-part stream from my stream going up and down all the time. It's pretty frustrating when that happens. You're watching a streamer and they're having trouble keeping the stream up. That's a good time to just sit back and allow yourself the freedom of not streaming for a day. And I was right, because stream was bouncing all over the place yesterday. It would have been hell to keep it up. Don't take that out of context. I really want to package this thing up. I think it's high time that I do that. I just don't know how I'm going to cut the outside wall of the plastic enclosure, because this plastic enclosure is fairly thin. I mean, maybe I can just Dremel it. I don't really want to Dremel it though. I think the milling machine would be a bit more accurate to create just a little shelf back here. And then I was hoping that I could find a better battery, but I just don't think I have a better battery. What up, Flatulent Gonad? I meant to be watching your stream more, but I've been just all over the place today. I mean, yesterday, and the day before, and the day before, and the day before, and the day before. All over the place. We got simple electronic stuff to do, though. Look at my chips. I have a lot of 7400 series logic chips. A lot. So many. Three-phase motors. Oh no, what are you doing? We're getting into three-phase motors. It's a dangerous land. Ah, okay. I wish I had work stuff. Let's see. So is that... No, that doesn't turn it green. So it's still purple. I'm going to put a debug node on this. A good mix. This is Deckard on the Ripecast on SoundCloud. Under the Space Cowboys, and it is Party People 7 Brazil edition. I always play good music when they go to Brazil. It's almost like they're in a good mood. Alright, so let's see what this is. Bop. Where's my debug? Oh, I have to deploy it. Yes. Get source, class, boot pool. Oh, so dismissed equals true. Somehow it's still getting... So it's getting the two that I've dismissed. But I should be looking specifically at ID level format. I don't see where it's getting info from. If it's turning light purple, that means somewhere in here it contains info. Message payloads oh, that's a much... Oh, I see. There's more stuff down here. Huh, I wonder if I need to go through alert by alert and just make sure that there's nothing... Like, how do I open this up? Oh god, it's going to be one line. Notepad. New. Oh no, it's actually in something I can use, but oh no, but it doesn't give me the full thing. Somewhere in here there's an information level alert, but the dismissed true I should probably be looking for. But that would mean I need to parse through these individually. I don't know how to parse through them individually in Node. Did something just happen? No, nothing happened. Nothing ever happens. I gotta figure out how I'm gonna do this in Node. I gotta find something about this enormous message that I can get into and use to detect whether or not the server is having problems. How do I see the whole value? Like, I tried the clipboard over here, but that just clips... Yeah, that just clips this up until the character limit on the node thing, so... Oh God, there are still VODs that I haven't uploaded. I don't know how to free myself of this digital. I don't need to keep all of these. These are momentary, they're temporary treats, these streams. It's not like I would hire an editor either. I'm not popular enough. What is this? This is a sub message from Silly Russell. With 96 months, why did that turn off immediately afterwards? Wait a second. That should have lit up significantly, and maybe I just missed it? Something happening with this? Let me just try something. Then I'll look at the thing. Okay, that seems to work. So everything's probably working. I just don't know why it'd be like that. Oh my goodness. Oh my goodness, look at this little guy. Or gal. Look at this little lion. It's cute. Cute. It's so cute. Willow had a morning. She had a morning. The people to take a look at the generator came, and all the blips in power apparently like broke something in the generator. I think, I don't know. Our washing machine wouldn't turn on. The generator kind of evaluates how much current it can provide, and then turns off certain large appliances to not allow you to use it. And, in a power outage, sometimes the power can be out for days here, so you might want to do laundry while the power's out. You can evaluate whether or not you want to spend the money to do your laundry. And it is money. You're just converting natural gas into money and then shoving it down the gullet of some rich people in order to do your laundry. But the generator stuff like evaluates that for you. We had the generator on for like a week recently. And so when the power started glitching around here, one of those boards just went out. I don't know what happened to it. I would love to take a look at it, but I don't have it. The guys just replaced it, and they billed us $300 and left. But apparently, yeah, the brownouts yesterday caused something or other to go wrong. And it's like, Bother, you could figure all that stuff out. Well, yeah, but I'd rather let the Sparkies do Sparky stuff, because I don't want to be the recipient of a butt ton of 240 volts going through my chest. And they know what they're doing, and typically with those kinds of service jobs, you just swap stuff. So they knew what to do. One of my cats is black, and my sister wanted the cat to sit by the door with the rest of the Halloween decorations. If only. Easier to get a dog to sit by the Halloween decorations. Oh, boo-hoo, main singer. Just let the song continue on. Jeez, whiny little singer. He's just sitting there whining about last forever. Just, jeez. What else do we got in here? I keep finding presets that I should be making a playlist of these, and I just am not. Waterfall. Waterfall's not that good. And for you guys, it doesn't look quite right. I don't know. It doesn't look right on camera. This is close, but it's a lot brighter for me. It's hard to replicate what the Mark I eyeball is capable of seeing in a variety of different lighting scenarios. Plasmoids was okay. It just makes it kind of all light up. Yeah, LEDs wash out too quick. They've got specific frequencies of light that they output that the camera can either be super sensitive to or super insensitive to, and it doesn't match what other lighting is doing. It's very strange. Because right now, I see these as distinct colors that are little individual points of light. So this is actually a really good-looking preset. You guys see it as this smear of light. And I guess if I turn this off, it'll get a little bit closer, but the camera's still going to adjust itself automatically. So it'll be washed out, or it'll be too unserious. Kind of annoying. What are you saying, Hate Sack? She made it through the last one. I mean, I still need to finish this thing up. It kind of got bogged down in project land. Hey, there's the light. It does work. Keeper of maps. Keeper of maps. Thank you so much for the 69 months. Ahoy hoy. Hell yeah. Wait, what is this? This is not. Let's get the music out of here because we got some work to do today. We got some MS painting to do. And yeah. I think today's going to be kind of interesting because we are following somebody else's project. Until the idea light turns on. Wait, was it the sub or the idea in text that set this off? Because this didn't light, I didn't see the light up. I don't know. Commence with the fuckery. Yeah, what are we doing? Well, okay, so I want to do something else on this Friday. Missed a couple days streaming this week. We had a big rainstorm come through, which typically shouldn't knock out my whole stream. I should, theoretically, if a little bit of water is falling from the sky, I should still be able to stream. And I know mankind has struggled with hanging wires from poles to be perturbed by the tiniest of breezes. But it was actually like legitimately very windy and rainy here. We got a lot of rain in very little time. And so that gave us several brownouts during my stream. And those brownouts even caused damage to my generator system. I had to get that repaired today. So it was a bigger deal than I think I let on to. But it interrupted stream at a very crucial time when I should be getting lots of viewers and I'm not. Happy Halloween, everybody, though. Yeah, they did some cooking of the books or something and got us like under $300. I think, no, under $400. But such is the woes of having a generator. I mean, the generator was a great idea. The power goes out in this area a lot. A lot of trees, a lot of wires. And when it does, it's nice to have the amenities. The problem is the location where all of my e-waste is going, the thing that we're communicating with and the infrastructure in order to get to Verizon so that they can steal all my data and pump it into an AI, that goes down quicker when the power's out. So that got interrupted too. And so regardless of my power state, I was unable to stream. So, and then before that, this computer shit the bed. I had to do some stuff to get it back up and running. I really should probably redo this whole streaming computer and start fresh. It's getting to be about time. This one's getting kind of stinky. And you guys have seen that firsthand where my chat windows start parking for like to save memory. It's bad. But before all of this digital technology came the 7400 series of logic chips. 7400 series logic chips. They're not just logic chips. Is the food in the fridge okay? Oh, hell yeah. I've not been eating a lot, which is good. Boy, I've read some stuff. The people who are on these SGL1s, apparently, and I don't know who the hell they're talking to, but get people saying that they're like cheating, that this drug somehow magically makes you thin. What it does is it changes your whole mentality around food. I've read about people treating ADHD with the drug, and they're like, yeah, I'm not on it to lose weight. It just helps me not think about food all the time, which is incredible. It just kind of recontextualizes how you feel, how your stomach interacts with the rest of your body in order to give you sensations of hunger. There are probably underlying elements to it as well, doing other things to sort of your mentality, and that it's just incredible. It kind of shuts off the lizard brain, telling you, unga bunga, I need to eat now or we're gonna die. And it's crazy. Strong wind can be a problem. A colleague told me it blew away their solar panel into a river. They had to go scuba diving to get it back. Wow. That's incredible. Wait, no, you said colleague. Oh, there wasn't a U in there. Okay. Whatever. I can read between the lines sometimes. Anyway, before all this wonderful digital technology that takes over our lives and gives us this dopamine drip feed of information that is ultimately ruining all of society, We had 7400 series logic chips. These can do a lot of the functions that sort of digital technology does these days, only on a much less complicated field. It's basically the and, if, and or gates of your digital life. When you have a logic gate, it is a series of transistors that are put together in order to give you the function of having voltage on two or more inputs and have that intelligently affect the output. And they're nigh on instant. There's maybe like a tiny bit of delay. You don't have to worry about clock cycles, all this other stuff that you have to worry about with microcontrollers. If you put 5 volts on one pin and 5 volts on the other pin, you might get 5 volts out of the third. That's it. That's logic. 7400 series chips are sort of a blanket of functionality that all works at, I believe, at around 5 volts. CMOS is 10 volts or 12. 7400 series is TTL, isn't that TTL voltage, logic voltage, which is 5 volts, which is a bit of a problem for us because the synthesizer is 10 volts. So really what I want to do is just redo what Moritz Klein did on the Erica synths. Moritz Klein, just an employee of Erica Synths. Erica Synths has a whole drum machine based on this stuff, and it's all based on logic. You can have what are called flip-flops, which is where you trigger something to carry a bit over and hold on to it, which is a type of memory, but it's on these logic circuits. And so if you have a couple of these lined up, that's starting to look a lot like a sequencer to me. And so you can run through a sequence at regular intervals, kind of like music does with the drum. And then as you're running through these intervals, you can have a bit stored or not, and that will give you the functionality of whether or not you should have a drum hit or not. Very simple. It's very simple. Moritz Klein does an incredible job on their YouTube channel explaining everything. So that means that we could not possibly, we can't fail. We could not possibly fail. Because we have it laid out for us in such simple terms. Now, Moritz Klein, not in the business of showing us exactly what they're doing, and they're doing it for modular synths. So it's using CMOS, it's using 12 volt stuff. We have 5 volt stuff. So there's a lot of conversion there if I want to actually use it with any of the modular things. And I kind of do, but apparently the project is a sequencer and not a full drum machine. So I don't know where we're going to be making these drum hits from. I don't know what we're going to trigger. That's sort of something for future bother to figure out, right? Failure is always an option. What I'm hoping to get out of this thing is some nice blinky LEDs. That's what I'm hoping to get out of this thing today, and we'll see where we can get with this. Now, 7400 series logic. The chips are great. I've got tons of them right here. The CMOS logic chips that Moritz Klein uses have an equivalent in TTL logic. So we're going to have to find equivalent chips to what he's using. I had a little bit of Caesar salad for lunch. That's all I had. It's leftover from last night, and it's lettuce leaves and a little bit of dressing on it, and very, very little dressing on it, and a couple croutons. And my stomach has the audacity to be kicking itself up like as I'm trying to explain stuff to you guys, like why are you doing this? I didn't even eat anything. This isn't fair. This isn't fair. Let me get, what was I going to get? Oh, something to drink. That's what I'm going to get. And then we're going to get into this, and we'll take a look at what these logic chips do and hopefully produce a master schematic so that I can actually build something functional. All things considered, we could step through it the way Moritz does, and we could actually follow this sequence of events in order to create this thing. But I don't want to like directly, ape off of, I don't want to directly copy this. I mean, we are directly copying the circuit. We're just going to shuffle some pieces around. So if you guys want to take a look at the YouTube video, it's actually a completely fascinating YouTube video. I really like it. I love this channel too. I won't shove your guys' faces in the technical stuff, but yeah, let's put that into the Twitch chat. Bada bing, bada bangus. There you go. So if you want to see what this thing is and read ahead, you can. This notation is sort of quite a bit like a flip-flop. Flip-flop you draw as like a box, and it's got inputs and outputs on the box. But on the schematic at the end here, there it is. The schematic at the very end, oop, that's a very flattering shot. This is what I'd like to build, but having the CD4015 here like this doesn't explain to me how this thing is actually wired up, because the CD4015 is going to have a different pinout to what we want to use. So I'm going to break this out into my own notation, and we'll try to suss out how this thing is operating and sort of step through building it. So so we are using op amps to create our signals. So that's probably where we would end up boosting things out. So we'd boost our voltage level there, and then we could actually send it out into the rest of the modular synthesizer. But this is cool. If I had a couple of these units, you could probably do some pretty cool stuff. And the drums that were being sequenced off of this thing sound really good. But I think that's attributed to what Moritz is hooking it up to. So, all right. So we need an MS Paint diagram, MS Paint, and we need to just kind of bite into this whole logic thing. So, where are we starting? I mean, generally the logic behind a schematic, because, okay, schematics are symbols that represent parts, that represent connections, right? You have a symbol that'll communicate to the engineer what that thing is. And so when I see a big triangle with a plus and a minus coming out of the right side or left side, that's an op amp. That is a chip that I can put down and connect in the same manner that they have got it drawn here, and it will operate as an operational amplifier, which will boost an input difference of voltage by something like a factor of 300 until you feed it back into itself, and then you choose a resistor feeding back into itself, and depending on the configuration, it will give you less of a signal. It can give you more of a signal. It can give you the opposite signal, depending on how you set it up. What's up, Umbra? How you doing? Depending on how you set it up. So, you know, transistors, diodes, light emitting diodes. You can see the difference between a diode and light emitting diode is 2 arrows. I don't have a lot of diodes. I don't have a lot of through-hole diodes. I think I need to buy a reel of them if we're going to be doing breadboarding a lot around here. I don't have a ton of diodes, though. I do have a ton of surface mount diodes, so maybe we could put those onto the breadboard in my own little way. I use female headers, and I solder down the 2 legs of the diode, and then I can plug that into the breadboard. I am just going to be copying down elements from this, and then when we get to the CD4015, that's where we'll split it out into its individual elements, because that'll help me translate it into an equivalent part. The CD4015. I do not have a CD4015. I have some kind of a 7400 series equivalent, because I bought all these 7400 chips on eBay. The thing is, CD4015 is CMOS, 20 volt rating. So this thing could be hooked up to the plus minus 12 volts of the modular synthesizer, and then it would be able to operate with these voltages. I have so many diodes and LEDs. Can't live without them. What am I going to do? Like, I guess I need to order like 1N4148s by the bushel, because it's going to, like, soldering surface mount diodes is going to be very annoying for this. I'll live with it. We'll do it anyway. But yeah, VDD to VSS, about 10 volts. So you could run this on plus 12 and ground. All right, Poopsie Doodle. I already gave you credit earlier for, what was the Poopsie Doodle credit? Oh, for software and game development as a potential category. Yeah, next time we do like microcontroller programming, we should jump over to software and game development. Although then we'll get all the eggheads that want to correct everything I do. So the CD4015 has 4 flip-flops in it. It's generally for turning serial signals into parallel signals. So you get a bit coming in, and then you flop it over to the other set, and then you flop it over, and you flop it over, you flop it over, until that serial signal can be put out on parallel. It's not vice versa. It's actually that direction. There's a lot of inverting going on here. These triangles without plus minus in them and a circle on the front are inverters. So that's just inverting the signal. If there's a triangle without the little circle on the top, that's like a buffer. It's not inverting the signal in any way. And these are all ones and zeros. When we're dealing 7400 series and CMOS logic, logic implies that it is a 1 or 0 type system. We're not talking about analog voltages coming into this. These are fundamentally analog components, but they're operating digitally. They are putting out ones and zeros. I like triangles and circles. Yeah, you get to do all kinds of weird doodling when you mess around with electronics. All kinds of weird doodles that are something else. So what's happening here, basically, you have a data line and a clock line. So clock and data, ones and zeros. The clock is going to be 1 0 1 0 1 0. That comes in and basically gets flopped over and over and over. And then when you reset, everything goes back to 0, and you're ready for a new input. So it's kind of cool. If you hook up LEDs to all this stuff, you can see it like charging in. Your stuff is like physically moving into the data register. It's kind of cool. This would be a way where if I have like a number that's being communicated serially, I could put it into parallel logic for like a BCD decoder. So I could make a number out of it on LEDs. Took me a while to understand op amps, mostly different configurations with the components within, but at some point I'll be able to recognize patterns from schematics. That's memorization. Basically, when I do stuff with, like if I'm looking at an op amp circuit, I've done it enough that I do kind of know, but you could just look up like top 10 op amp circuits. And then you get the 10 fundamental operational amplifier configurations. So you learn to recognize these. In reverse engineering, when I was doing reverse engineering, if you had a circuit that had all of the elements of this, sometimes whoever's drawing your schematic, or if you're drawing it yourself, reverse engineering something, you can tend to put these all in the wrong places, and you have to kind of reconfigure the layout in order to communicate that, yeah, this is an op amp circuit. You know, we're differentiating here, or we're integrating, or we're, doing a conversion voltage thing. But yeah, top 10, just a list of op amp circuits. You just look at them and figure out which one's which. So flip-flops have always kind of eluded me. I'm not good with these things. I don't know exactly how they are working, but I guess it's carrying a bit over to the other side. So you got a bit on one side, you hit it with a clock, and it'll carry it over to the other side. Yeah, I guess that's what they're doing. So the CD4015 has access to all of the different stages of output, and it's got 2 groups of 4 flip-flops in it. So we need to find an equivalent 7400 series chip that does the same job, only in 7400 series logic. So what is this called? Dual 4-stage static shift register. So static shift register. 7400 series is done, which means we have a finite pool of chips. Now I don't have a list of these. I don't have these listed out. I probably should have cut paste. 7400 series used in a lot of electronics lessons, also fun. Yeah, logic used to be a much larger part of the journey through electronics. Nowadays, they are completely and utterly obsolete, although their speed still gives them an advantage. But now you have microcontrollers that have programmable logic sections in them, where you can just throw like, oh, here's what logic thing I need, and they're just as fast as putting together a bunch of these chips. But these are more fun to do labs and stuff with, because ones and zeros. You can hook up any of the pins of these things to an LED and have a flashing LED that's showing you what your circuit does. That's the fun part about logic. But we're done making them. Well, they probably still make them. It's just they're a finite thing. There's a list in Wikipedia of 7400 series. So we need a dual 4-stage static shift register. Let's try static shift register. Static shift. Phrase not found. This isn't a good list. The good one was on Wikipedia. Here we go. This is the one that I was looking through yesterday. 7400 series logic chips. There's a couple. there are a couple of these chips. These were sort of a staple of complicated digital electronics back in the day. You would use 555 timer. Leaves a bad taste in my mouth just saying it. I hate 555 timers. That's actually a controversial opinion. Electronics people love them. But you used to put a 555 timer onto your board. You would figure out through just dark, evil equations what capacitor and resistor you were putting on your 555 timer. That thing would give you a regular interval, bop, 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 bop. Then you would trigger that thing with logic, or have it trigger logic in order to perform a task, right? You do stuff like that. You wouldn't go into a microcontroller and say delay 20, LED on, delay 20, LED off. You would get a 555 timer, figure out that. If you wanted anything more complicated, you would then use a series of logic chips in order to activate and deactivate different functions, right? This is essentially what we're going to do. We're not using a 555 timer, I don't think. Maybe we are, I don't know. Yeah, I mean, in a lot of electronic scenarios, you do not need to jump down all the way to logic chips, because some microcontrollers even have an area that you can do logic in, or you just put it in your code, you know, and you can do much cooler stuff with microcontrollers. So this stuff is a lot of fun, but it's purely just for fun. Like, we're going to be making a drum sequencer out of this stuff. I could make a digital drum sequencer today in an hour. I could just throw somebody's code onto a microcontroller and it would have a screen. So doing actual stuff, you know, logic chips died because of the microcontroller and FPGAs. Yes. Yep. Show some respect to the 555 timer. No, I will not. I have a couple of them. People have jokingly sent them into me. I have no respect. I can't see what you're... Oh, I wanted to, like, hide the contents. I guess I can't. Okay, anyway. We are looking for a static shift register. Quad static shift register. 7477. Okay, so we got to keep the numbers low on the ends of the part number. The thing about the 7400 series logic chips is they work at TTL voltage, 5 volts to 0 volts, and they all have a part number 74 something something number. Those 3 numbers at the end we're looking for. We want to keep it like low. We want to keep a low number on these, just because your typical run-of-the-mill frozen microscope. Hold on. Microscope, properties, deactivate, activate. That should be coming back up. Deactivate, activate. God darn it. Okay, I gotta plug the microscope back in. Dag nabbit. It's USB micro. I really should convert. I've been meaning to convert this into USB-C because USB-C clicks in. And I actually have a screw-mounted USB-C that I can use on the microscope so it can move around and still be good. In school, I built a PWM circuit with a 555 timer. It was cool, but pretty niche. Yeah. Nice collection of 7400 series. It's as big as my head. At one point, I got rid of all my 7400s and realized that I do projects for fun, and 7400 series projects are fun. So I had to buy the chips again. Cool thing about these chips is that you can do very complicated stuff using very simple circuit structures. And then, because it's all running in 5 volts, you can just throw an LED on stuff and it will show you what's going on. The microscope setup was a bunch of happy accidents that I ran into. I'm not unfamiliar with cameras and productions and studios and stuff like that. You know, I used to take photos of IEDs for the FBI. Like, I was cool once. But yeah, anyway, so with the microscope setup, I just happen to have a Nikon, the Nikon camera lens that people don't like, the 18 whatevers. Bought a C-mount adapter, bought an enclosure for a webcam, and put a webcam on a Naga arm, which is the nicest magic arm that I own. And those elements together give this amazing microscope setup where I've got, 2 feet of standoff from the lens. Pretty cool. It's better than just flipping a lens around. Father secretly loves the 555 timer. I hate it because you have to go into weird equations in order to figure out what component values you throw at it. And then when you go to get those component values, they're not those values because everything is a statistical probability in electronics. Logic is a little bit more binary, but when you're dealing with resistors and capacitors, everything is fucked. It's just none of the values are exactly what you're equating. Your equations are going to be slightly wrong. Your circuits are going to be slightly differently laid out. You're going to have one element that maybe doesn't connect all the way, and things just go south. And it takes all this time and know-how and pokery to get it running again. So no, I have no love for the 555 timer. I have no love. Anyway, so 7400 series, 5-volt logic, USB voltage. We could probably power this thing with the computer if we wanted to, or, I can bring in the power supply on this. We need that static shift register. 747731 I'm not going to have. My numbers, what I was saying is that my numbers, we go up to 74. Why is this still not, this feels like it didn't actually calibrate. Hold on. I think it you know what, if I restart Stream Deck, let's quit Stream Deck and start it up again. Then I have to calibrate the camera because this shouldn't be leaving trails. Well, you can see here we're up to 7422. Oh my god, it's so clunky. Oh, this desperately needs 373. Why is the frame rate abysmal? Okay, let's whoa. There we go. That's much better. So yep. We go up to like 54, 374, 800 I don't necessarily have. 7731, 373. These are in a weird order. These are the larger chips, and I think the one we're going to be looking for is probably going to have a lot of pins coming out. I don't know if styrofoam is recommended storage. It should be that static foam typically, but styrofoam works just fine. 374. I've never really had a chip go dead on me because I static shocked it. Just by 1% resistors for everything. That's what people are doing now. Back in the day, you couldn't really do that. It sounds like the other corgis are here. I should instead have the cameras upstairs, where all the corgis are. I scared her with a glass of ice. I accidentally dropped it, and so Willow went all the way back up to my room this morning. Okay, we're looking for a static shift register. This is the only one. Really? I mean, we need a lot of shifting going on here because we have two. It's a dual 4-stage. Let's see if we can find dual 4-stage. No stage. Dual 4-bit shift registers. Wait, that's right here. 4015. It's right under our nose. Hold on a sec. Why? Yeah, okay. Maybe sometimes you want to read the things that are on the page, Poor dog. I know. I'm a monster. I was giving her a piece of ice to chew on, and I dropped my glass, and I went, blah, 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 and the ice fell out, and she just got away and looked back, because that's what she does. She'll get away from a scene and look back at it. And so she did that, and I said, it's okay, Bubby. I'm sorry. And then she just went, you know what? No, I'm out, and just went upstairs. But I guess she's got a friend over right now. She gets to play with another corgi. 4015. So let's just click on the data sheet here. Or is there an entire... Okay, you know, I go to click on the thing and then it chooses that moment to trigger like a partial scroll. So you end up clicking somewhere else. I swear Reddit does that purposely to get you to click on weird stuff. And then it goes, oh, so you're interested in this weird thing. No, I didn't try to click on it at all. To help with your power bill, Smith Clay, thank you so much. And maybe a boat for the rain. Yeah, that was hell. We actually, that indeed will help go, but not into the power bill. It's going to go into the repair technicians that we had here today. Whatever connects our dryer to the electrical system here is mitigated by part of the generator systems. So if the power goes out and goes on back again real quick, we have to wait a little while before using our big appliances on the 220 volt lines. The dryer was very low priority because you have to, if you're missing electricity for like a month, you may want to do a load of laundry, but if you're missing it for a short amount of time, might as well just not have the dryer on the systems. So it gets a lower priority. Whatever made that decision was dead. So we had to get it replaced for a couple $100. Wonderful. I love modern life. I mean, hell, I would just put clothes in the bathtub at that point. You know, just fill the bathtub, throw the clothes in there, get a mop handle and just just stir it around. Don't need a whole ass washer dryer, but we have the option to. Maximum frequency 60 megahertz. Well, we're not going to get anywhere near that. Positive edge, overdrive reset, buffered inputs and outputs, fan out over temperature range. Don't care about all that stuff. Significant power reduction compared to LSTTL logic ICs. Listen, man. November 1997, revised in 2003. All right. Datasheet acquired from Harris Semiconductor. All kinds of neat little information. 4015 consists of two identical independent 4-stage serial input parallel output registers. So if you have a number that has a clock signal on it, that's serial, this thing will turn it into parallel lines that are holding on to a number, basically. Temperature ranges and stuff. This is 5 volt logic, right? Yeah, VCC of 5 volts. So I think this is an equivalent to what we were looking at. We 2D and 1 clock position, 2 clock position, MR, and then the shift over, and then the 4 stages of the shift over. So this is us. So I'm actually going to take an image of that. This is a good place to get your image for your schematic because all the pin numbers are on this. It lets you, when you go to build the circuit, you can turn your brain off and just say, oh, pin 13, done, connected. Some people even print out the schematic and go over it with a highlighter while building the circuit. That way you know what elements you've built and what you still need to build. Moritz Klein's video has the entire build right in front of us. I could literally just copy that and not think at all. But since we are going from one system to another, we're going from CMOS to TTL, all of the same components are there. So we're pretty much going to be putting together the same thing, but we can't trust that our pinouts are going to be the same. So first of all, do I have a not CD 4015, a 74 something or other, not a CD 4015, wait a minute, we're looking at a CD 4015. You sons of bitches. Is that an equivalent column? CD74HC 4015. So it does have a CD in front of it. 74HC 4015. Whereas the CD 4015 is up to a 20 volt rating on it. So we're looking for the 7400 equivalent of the 4015, which is the 4015. So LS, I remember it being like up in this section because these are kind of in order. 374. I don't know if I have a 4015. 374. 374. Actually, I think this might be one of these is that a dog in the window? I hope they're checking to see that the dogs don't get out because that gate is open. They could just run away. I took Willow out onto the back porch and the gate was open. We have these little like portable gates that we put out to keep the dogs contained and not have them chase after stuff. And so I'm sitting there with the dog and the gate's wide open. And I'm like, you know, you could just run. You could just run away. She didn't. She stuck around. I think she likes me. I was like, Willow, this is your chance. You could just go. So I don't have a 4015 specifically. The TTL and Logic systems came one after the other, and they do just about the same thing. One is just lower voltage. So there are equivalents of each type. 54, 279. So 279 is below 400. I don't think I have it. I just don't think I have the part. 401B, LS16, LS138, 125. Okay. So it'd be 40, 161. Yeah, okay, so I don't have it. That would have been convenient because it's the exact same part. Okay, so we don't have this. I'm not cutting and pasting that. Let's cancel that. Go back over to here. We don't have this. What did they call it? 4-bit shift register. So dual 4-bit shift. It doesn't necessarily have to be dual. We could dual 16-bit counter. That's not going to do it. No. Oh no, instead of dual, I can just 16-bit shift. 16-bit serial in, parallel out, shift register, output storage registers. 74673. We don't go up to 600. We just 674. You can use one of the 164s that you have is the 8-bit shift register. Okay, so yeah, well, hold on. I'm going over this part just so that everybody sees the process. If I find a 673, 691, and then we jump down to 3. So I think these, in ascending order, it starts down here and it goes up row by row in number. So low number, high number. Yeah, wait a minute. This is 8-bit, isn't it? It's 8 positions is what Mortiz designed with. So let's stop looking for 16-bit shift registers and drop down to 8. 8-bit S. 8-bit single supply. Why are we in the 700s, Wikipedia? What are you doing? Search it from up here. Eight-bit shift register, serial in, serial out, gated input. Not quite sure what that is. That's a 91. 40. Yeah, why is it? Okay, so bottom of the page, top of the page. There we go. Okay. So 74 LS91 could potentially do it. Although, is it going to do the same thing as the shift registers, or do they have some other kind of added thingy-wingy? Yeah, so I can't get to... This has a ton of non-connects, and the internal logic diagram shows that it is not something that we can extract individual positions with, which is sort of, you know, fundamental to the operation of this actual device. So we can't use that. Bonk. So we continue our search down the list from the top. 8-bit serial in SIPO, serial in serial in parallel out shift register, a SIPO, 74 something 164. So that's probably going to be our good bet. And that'll have all of the same functionality. It's just not a dual chip. It is a singular whatever. 174, which is, wait, 174 is what? That's probably not. 7374 hex D flip-flop. No. So 164 is what we need. There's a 165. 165. 165 is which? 8-bit parallel in serial out PISO. Wait a minute. It's called a PISO? 8-bit parallel in serial out. Oh, parallel in serial out. Oh, okay. A PISO shift register. We need SIPO, not a PISO. So we need the 164. 165. 165. Okay, I've got a couple of these pissers. I have a few pissers here. I guess these are good for getting parallel stuff into a microcontroller. 164, here we go. Yeah, it's just the line below. I have not used these yet. I got a bunch of them. We are only going to need one. So let's just get this sucker out. The leash lights up huge when you set off farts. 74 LS164 from Motorola. That one was like red. Ugh. Okay, we have one chip. 74 LS164. All right, put that aside. We have a second CMOS level chip here. Oops, that's too much information. This reminds me of the one electronics shop in Singapore that sold all ICs in bulk for dirt cheap. I have a bunch, but I don't know what to do with them. The winds really are strong there. If you guys haven't noticed, I've got a preset running on the dog collar. I have not been able to make this thing. In the future, I'm going to make a playlist that'll cycle through, like every minute it'll be a different hand-selected and catered visualization on the leash. But for now, I'm just sitting it right there just so we have something interesting happening with audio. So when a physical sound is in the shop, this thing reacts. So anyway, we need to get our PISO unit. No, we already got our PISO unit. So now we're getting not a SIPO unit, serial in, PIS out. We need a CD 4520. So I'm going to look up that data sheet. CD 4520. Ding. CD 4520 from Texas Instruments. There it is. Wait, HC 393. No. You're still making them? That's a current part. Crazy. 40 something or other. Dual binary updog. How do I get rid of this side thing? Get out of here. There's probably a way to do it that I just don't know. Okay, anyway, trying to like asymmetrical all of my visuals here. CMOS dual updog. So the CD 4518, which CD 4520, 4520, dual binary updog. Dual binary up counter. Are we going to be able to find that? Binary synchronous counter 74453. I can tell you right now that we don't have one of those. Let's go up on this. This is the first time we're seeing it. Okay. Up down counter synchronous preset input. Dual binary counter synchronous. And this thing is, okay, so it's an up counter. Two identical internally synchronous 4-stage counters. Jesus. Dual internal synchronized 4-stage. Oh, this is back in the day when they gave you a picture of the die. This is actually what's printed on the silicon of the chip. Suggestions for books to learn electronics. For analog stuff and older stuff, I learned on this thing. But that's also pretty well outdated. The Radio Shack engineering notebooks were really good for the initial electronics knowledge that I got back in the 90s, early 2000s. Things are way different now, though, because you can jump into microcontrollers and do some genuinely crazy stuff with them. We're doing sort of electronics super fundamentals here right now. We're copying a Moritz Klein design for a drum machine, which is using 7400 series logic chips, which are well and truly obsolete these days. There is no strong purpose for these to exist aside from testing stuff out on the bench that maybe later would go into something like a programmable logic chip, a PLC, or an FPGA. Okay, dual BCD up counter, dual up dog. I don't know why there's a big diagram of a shift register down below, but what is it doing in this? Well, we need our own equivalent up dog and a binary. So let's do, or I should do an up counter, dual decade up down, 454s. I think I have a couple of those, 454s and 453s. These are if you wanted to get a parallel count going from a pulse. And then you could put that parallel into some kind of a decoder. Got a bunch of 374s. These are, wait, what were these? 691. Yeah, I guess we're kind of lacking in the 4 areas. 240. 241. Now, why do chips get obsolete? Are the newer ones just cheaper to produce? They are getting currently produced, and they would probably be cheaper, although secondhand purchasing of chips, like if I was going to do like a big production run of something, I wouldn't be putting logic chips in there. I had a Nintendo controller that prevented you, well, okay, so classic example. The way a Nintendo controller worked back in the day was it had a type of shift register in it. It's the opposite type of shift register that we're using. What would happen is if you have buttons pressed down, it would, the Nintendo would latch a signal that would freeze all of the button inputs. And not physically, obviously, you could still hit buttons on it, but it would freeze them into the controller's like shift memory and then send a pulse. And for every pulse, it would get a 1 or a 0, depending on whether or not you were hitting that button, right? So turbo controllers came along and they added one singular piece of logic in between you pressing the button and a clock signal. And so that separate clock signal would come in and it would da-da-da-da-da-da-da-da. And when you press the button, the logic would say, okay, now we can output. And so then that would output 1 0 1 0 0 0 while the base station just pulled those button presses. So that kind of thing is what we used to do with logic. Nowadays, the buttons are all being like timed on a millisecond basis or microsecond basis so that they don't bounce up and down, because the microcontroller is polling them much, much faster. I mean, you can do some fast stuff with the shift register, but the microcontrollers have taken over because they have a vast, complicated amount of functionality, whereas with this stuff, it's all very simple and it's all very direct. I tried an O-Bother reverse engineering temp and failed. Simple timer, passive infrared that I wanted to make faster. Looked like the 555 on board with no markings, but I think some CMOS programmed internal time that used a voltage reference for the time. Interesting. Changed some things. I thought I would control a 555 timer and nothing ever changed. I failed. Yeah, a lot of PIRs now may be using higher intelligence. There are chips that control PIRs. I don't remember. I've gone through a lot of PIR, passive infrared circuits. Those sensors, what they're doing is they have two silicon pieces of silicon that are sensitive to thermal stuff, and if there's enough of a difference between the two, they go off, right? Everything beyond that, it's all very wishy-washy, right? Certain tunings will set off certain ways. So we're looking for an up counter. The 454 is probably what we'd want. I thought I found a good equivalent, but I didn't. If Ben Gizmo has an idea, but 4520, the CD4520, and it's a binary up counter, and what it does just increments a counter on its pins. Do you have a 69? How dare you solicit me for such a thing? Let's see, 109, 112. I know you're not joking, but I took the opportunity. You know, seize the day. Kiss your homies. You know. LS04. Got to go all the way up to 60. It's very loose, the organization of this thing. I should probably reorganize these so they make more sense to me. It's like counting the wrong direction. 55. 86 is on the above. 73, we've jumped. LS, we go from 55 to 73. So is 69 up here? These are the larger pinouts. Two, 4, 5, 3, 7, 3. 240, 3, 6, 7. Wait a minute. Yeah, it doesn't look like I have one. Dun 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 dun. 74, 373. It was like back in this day, if you wanted to move something out of memory, you would do it with these chips. Crazy. You would use up and down counters in order to access memory locations. Is 69 a counter? I think I've seen it on a large 7-segment display. I don't know. I was trusting Ben Gizmo on that one. We need updog, so I need to find this updog. It doesn't necessarily need to be dual. I could just do 2 chips, right? Counterpart. 68, dual 4-bit decade counters. That's a decade counter, though. That counts up to 10. We are... What kind of counter are we? Dual binary coded decimal. BCD is binary coded decimal. So you had a 691, that might do it. So binary is 1 to 10. Binary coded decimal. Binary coded decimals, I think, is different. Is that right? Just give me the image, please. I'm trying. There we go. So BCD versus binary versus just counting all the way up. These last ones are ABCD because where you can't represent 10, 11, 12, you ABCD on that one. So you can have like a, yeah, binary number represented as blah, 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 blah. These are like months of courses that I'm sort of rehashing here to try to explain myself. But anyway, in BCD code, we have that much stuff hanging out. Just keep that there. So I can't use a decade counter, right? A decade counter is not going to do the right thing. Get in there. It's been a number of years, but I remember for some strange reason. Yeah, it's man, not much. What's up with you? My brain is like leaking out of the other side of my head as I try to go through all this stuff again. But what excuse do I have? It's not like I have a high-paying electronics job. So, all right, anyway, we're just going to need some kind of a counter. And so a decimal counter is not what we need. 4-bit decade counter. So binary coded decimal, in this case, these are 2 4-bits. Dual BCD up counter and dual binary up counter. Each consists of 2 identical. Oh, wait, it's not BCD. We're binary. 4-stage counter. So it's really like it could be like an 8-stage counter. I don't think it's being used as that, but 4-stage counter. 4-bit. Just counter. Decade counter, no. 8-bit bidirectional binary counter. That's 269. I don't know if I have that. 240. 7950. No. 241. 244. 244. 245. Damn it. That one's probably 44. Yeah, it's 44. I'm not, like, if I was looking these up individually, I guess I could figure out what they are and whether or not they're equivalent, but 245. Was I looking for 269? Yeah, all right. Up to 373 now. So we don't have that. Decade counter, that's not going to work. 4-bit binary counter, 293. We don't have 293. What was the highest 2 that we went to? 245. All right, find the next one. You know, I got all these chips, right? I'll definitely have the right one. I had a 691, 390, 393, 4-bit binary counter, asynchronous clear. That's pretty much what we need. 74LS 393 or 390. I don't know why there's so many parallel functionalities, but 373. 691, 374. What the? Yeah, son of a bitch. 600, 3 to 600. Oh, you bastard. 3938. Let's see. 8-bit D-type register. No. That's 390. 390. I'm wondering if this would be a genuinely expensive chip, too. You have a 691? Where is it? That's a binary counter? Oh, it's right there. Let's take a look at what that one does. 74LS 691. 5, 6. Oh, 48. 650, 660, 70, 80, 691. 4-bit counter, latch, multiplexer, asynchronous clear. This might not actually do what we want it to do. What is this data sheet contained in? Oh, it's an Internet Archive. 74LS691 data sheet. Just let me see that beautiful PDF. Okay. Oh my God. Oh, I don't need to know this. This is so much. What does it look like in like a normal schematic? Oh my God. What in the hell? Oh boy. Whoa, okay. Let's find out what Moritz is using this thing for, because watch it with them links. Okay, so good Lord. Synchronous counters with output registers and multiplex 3-state outputs. It's only 4-bit. You would need 2 of these. Yeah, I do have multiples. We have a bunch. I just getting a sense of what this output is at all. Let's take a look at Moritz's design. Oh no, I think I'd only need 1. They're only using 1 counter. Now, Moritz explains the use of this thing very well, and I was asleep during that portion of the video, so I don't precisely know what he's doing with this. I think it's a timing. It has to do with throwing up a different timing onto this thing. So I guess if we're using that one, I would like to find a better data sheet for it, one that's not telling me the fundamental like construction of this thing, because it's a little bit intimidating when you've got this as your equivalent like pinout. Normally I ask for sorry, it's been on Halloween pop binge. That's all right. It's all right. Oops, that was the wrong. I just did the procedure, so all the visuals are going to jump around. Oh, did it just uncalibrate my... it just uncalibrated my camera. Now the frame rate's all weird. What the hell? That's so weird. Okay, and then it pops back and everything's fine. Yeah, there it is. Okay, so I had to do it twice to somehow refix my camera. I was going to do a joke where I actually was mad, but I'm not. Okay, so this we don't need. This page we don't need. The 7400 series list, I guess I'll leave up. The Moritz Klein stuff. What is going on in this circuit? Well, the CD4015 is doing carryover bits. The counting is, the CD4015 is all, 8 of the locations that you can program with a drum beat or not. He breaks it down in this video, but it's basically your sequencer is going to be like a 2-button sequencer. One of them is, well, a clear button too, but you basically hit the drum at the time and then it'll keep repeating what you've done. So 4 bars in a 4/4 song. So you have 16 locations and you have ons and offs. So bump, 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 bump. If you want to have anything more complicated than that, you're going to need to have something to do different timings. And I think that's what the CD4015 is doing. Is it being, so where is it getting the counts from? I need to be able to zoom in on this thing. So I guess I'm going to take a screenshot of this schematic with der Snippen tool. And be sure, by the way, in the YouTube video down on the thingy, there's a thingy that you can click to go to his thingy. And you should all absolutely watch this video because it's a good video. And it really breaks stuff down nicely. And we could sit here and have him explain to us everything that's going on, but I don't want to just watch their video. I would love to zoom in on this snipping tool. I guess snipping tool doesn't zoom. So into paint. We live and die by MS Paint on this channel. All right, so we got gate out from an op amp. That's coming out of 1A of the CD4015. The CD4015 is flipping and flopping all over the place, right? That thing is flip-flopping from some kind of a source. We have our halftime clock 0 and 12 coming from the 4520. The Q0 is the lower setting. Upper setting is hanging, unless that is cross-connected. The frequency is adjusted via op amp, and I guess our original counting is coming from mod depth. What? Coming from the transistor circuit over here. Accent into the op amp circuit. So, I mean, we're going to need a quad op amp. I have those. Those are in different bins because those are analog. They're still relevant. And yeah, we got them just sitting over here with the music stuff. So we'll get that out too. All right, I think everything, I have a basic idea of how this thing is going to function. I think we have all of our equivalents that I think will operate in the same manner. Only we're just going to be doing it in 5 volts instead of, 10 and 12. And then in order to get signals out of this thing or into this thing, I will have to build buffers. But the only buffer that we got around here is Willow. Man, I went through all this trouble to program a reverse engineered Bluetooth low energy controller to replace this $100 circuit board that goes into the steering wheel, and it's a wireless wheel system. One of these is dead. The other one is brand new. I needed to get one more digital signal when I accidentally had to kick the bucket. The whole thing. And a viewer bought me the second circuit board because I killed one of them. And they were nice enough to buy me the second one. But really, what I should have done at that point, not at that point, way before I got to that point, I should have said, hey, you know what? The open wheel project is good enough at this point that I could just program a LIN bus module for it. TL074, there's a TL072 and TL074. 74 means that there are 4 op amps in this. So we got our 4 op amps here. We've got our, what were we doing? We're using the 691. Supposedly we'll need one of them to do our, I think, half timing. Moritz in his video has all of these wonderful drum noises. I do have modular stuff that I can make drum noises with. I don't have it hooked up right now, so we're going to have to function off of LEDs. I can't get this thing out of here without damaging it. I need to use the tweezers. Use the tweezers. Because if this is good, I kind of want to build like a couple of these and put it into my modular setup. Marbles kind of does the job of making drum beats, but it kind of makes these sort of static marching band kind of beats. So I want to see what I can do with something like this, because I like the cut of its jib. It's using very, very simple electronics and no advanced programming or anything like that. Okay, so the next tool we're going to need is a solderless breadboard. This is where circuits typically are invented. This is like the first stage of building a thing, is not to sit down and start soldering, but to use solderless breadboard in order to get all of the functionality out of the thing that you can, and then you go and you solder it. Or so that used to be the process. You used to go and solder it onto a perforated prototyping board because you knew your circuit and it was locked in and everything was going to run in exactly the right way. No, nowadays what you do is you design it on the solderless breadboard, and then you can jump immediately to building a circuit board. At least that's kind of how it used to be. I'm not totally sure what, I haven't reevaluated my process, because getting a circuit board, you could get 3 or 5 of these puppies for $5. So you could jump directly into putting your design onto a PCB and just order that instead of building something on, you know, perforated prototyping board that could be a little bit more fragile than a PCB. It's insane. It's insane. You just go directly to the stage where you're building a product. Wild stuff. Anyway, solderless breadboard, totally necessary for a project like this. What this does is I press electronics into this thing, and there are metal clips inside of it, and those metal clips short the contacts together, basically, right? So if I bring one, I have one that's translucent, you can see by the side of the thing that there are clips, and every 5 contacts are connected together with a clip and then isolated from the ones next to them. That's it. That's all it is. So 5 clips, those connected. On the sides of the breadboard, we have our rails, and the rails are continuous. Now, every now and then you will run into a breadboard where in the middle of this rail, it'll be split. So you'll have 4 rails inside of this thing. That could be convenient when you're doing stuff with like modular synthesizers, because modular synthesizers use all kinds of weird voltages, right? You'll have 3 volts for any smart stuff, 5 volts, plus and minus 12 volts for the op amps. In this case, we're not going to be doing that many voltages, but you know, hey, yeah, so sometimes they'll split here and you'll see people just put contacts in there to bridge them. I know these are continuous all the way down. All right, so our circuit, we have our elements here, we have our op amps, we have our counter, and then we have our whatever that other chip was. I guess what I should start with is creating the, what is it, the rhythm, the actual, where the circuit begins. Before we do anything complicated, I need something down here, this stuff. LFO out, accent in, mod depth, and then these guys, LFO sync. Where are our, oh, so half notes and eighth notes, quarter notes. Oh, this is our clock. What is, wait, what's going on there? How's that a clock? Oh, it's just showing the clock coming from the CD4520. Oh, there's the clock down here. That just goes to clock, which comes from here. Where does it all start? Let's go back to the video and find out where this all starts. So I think he's getting an external clock. We need to make our own clock. Yeah, he's just showing what this circuit does. Always good freeze frames. So I need some kind of a clock source. So here I am, consorting with the devil. What's like... metronome circuit. That's outputting to an 8-ohm speaker directly. I don't think I want that. But anyway, we're going to need a 555 timer, unfortunately. Because rhythm is time. Oh well. I know, something 555. It's I'm making a deal with the devil today. Got to get the op amp out of here. I want to start at the beginning, so the beginning is timing. All right, so bite the bullet. Let's get the 555 timer out. I think I've got it in this bin over here, or I exiled it to another bin. I think these are all 555 timers, and I think most of these are sent in against my will. This one is even, no, this one's epoxy. You know the chips are old when they're ceramic. NE555. Cursed little guy this thing is. Cursed, cursed, cursed. What's going on? Why is this hard to plug in? Oh, it's just the leads have not been curled. Give it a little flattening pass there to straighten out these leads, because when these chips come from the factory, the leads are coming out at like a little bit of an angle. They're kind of spread out like that, and so I roll them on the desk to kind of move them in just a little bit. Yeah, we can't avoid using a 555 in this case. That one's running off of 9 volts. We're going to be running off of 5 volts. So what's that going to do? Well, let's build this circuit. We're starting here. Let's build this thing up and see what happens. I was half inclined to modify the PIR with a 555. And I don't think that's what's going to be powering the PIR, but it might be something that simplistic. I know there are ASICs that do it too. Disther and Trig. So once again, we need to look up the data sheet for this thing. This is just anybody's old 555. It probably has an equivalent pinout to all the others, but I am not that much of a weirdbeard that I've memorized what the 555 pins are, because I hate them. I hate using them. Any 555P. NE555P. Help writing a review. Oh, you don't want me to write a review. You don't want me to write a review of this chip. Data chart. Where is it? Oh my God. Other names. The Devil, Lucifer. Veclar. Featured product, data sheet. NAF 555. NE 555. There we go. The NX555 devices are blah, 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 blah. Pins, there we are. All right, so I guess what I'm going to do is set up a 5-volt rail. We'll set this up as a 5-volt rail. I don't know if the op amps are going to need 12. Does the... Oh, we'll look that up when we get to it. So we're just going to do 5 volts for right now on this outside thing. And I need a kit of wires for solderless breadboard. I have several. And then we need to make the same jumps that I make in all of the other breadboards. So these are clearly going to be missing all those jumpers because I've used them in the other breadboards. So VCC is on pin 8. Now, because through-hole electronics is an offshoot of vacuum tubes, a vacuum tube has its pins in a semicircle with a gap. So we have a gap, and then we have pins in a semicircle with a marking that tells us which one is pin 1. That was originally how vacuum tubes did it. There was no gap on the other side. It would be a semicircle of numbers. So when we count the pins, we have a gap with a mark, pin 1, 2, 3, 4, 5, 6, 7, pin 8. So pin 8 is over here. So this one has to go to the positive rail. And so I find an equivalent jumper, which is impossible because all of them are used in other projects. Let's make the best of it. This one's stretch. Well, that's a good ground. Ground is on pin 1. Okay, so but that one also needs to now make a big jump. Damn it. What up, Blowfish? All of my jumpers are gone. I may have to get like a new jumper kit out of the box here. Yeah, I think I do. Unless I can reuse some of these. We've had so many big breadboard projects lately. Average pin 0 enjoyer. No, you don't. Okay, pin numbers. I already love what you are about reading your stream title. Awesome. No, we don't do pin 0. We're not freaking programmers, although electrical engineers are tasked very often to be everything. You know, we have to be able to program both in MATLAB and in C code and Python and blah, 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 and operate CAD software and do all these other specialized things. Programmers love to lord pin 0 over you. We don't have a pin 0 because there is no 0th pin. There is a first pin, 1. So we don't do from 0. And anything that they would call pin 0 is a specialty pin or a label made by a filthy programmer. Disgusting. All right, I need a new breadboarding kit because I'm actually completely out of the length that I want. We've done a couple like synthesizer stuff with the lengths of wire in the breadboard, and it seems like there's one length, and if I could buy a kit that entirely existed of that length, then I'd be eaten. Okay, I think I'm out of kits, so we'll just have to improvise. I'm looking through my big nasty electronics drawer. This is where all my good stuff is, all the surface mount stuff, and usually there's a couple kits kicking around at the bottom here, but you get all these like bins of multi-parts, and they gotta live somewhere. I'm CSC! So I pick 0. Well, the convention is there is no pin 0, so pinouts are done by not 0 indexing, right? And I feel the need to highlight and not allow you to be comfortable with 0 indexes. I have to call it out. Name and shame. Yeah, I'm not seeing a kit in here. I'm going to have to buy a kit of breadboard jumpers because I'm lazy. And it's only like $10. Well, we'll do that later. Okay, so I just got to improvise. I just got to make duty. I know there's probably not a lot of stuff is actually going to plug into the power pin, so I can use something that's like extra long. But like when you talk about what pin is connected to what, like that's not 0 indexed. You never see 0 on a pin index on electronics like this. Yeah, that's the thing is, yeah, just Semper Gumby. You just got to be flexible with that stuff. What's annoying is the power pins are all the way on one side and they're on the wrong side of this. It would be much more convenient if the power pins were on the other side. Engineering wise, I'm sure this makes sense to something, but now, did that actually go in or did it just bend my pin? Okay, that actually did go in. Sometimes these are like brand new because this is a new breadboard. When these come in brand new, all of these clips are going to be at their like clippiest. And so sometimes when you try to put electronics into them, they don't want to open up. So it can bend the wire and then have it not connect. And if you'll notice, none of this stuff is color coded. I am not following the conventions of color codes. I don't trust that. These are length coded. So VCC goes into pin 8. VCC is just an understood. There's something behind like VDD and VCC. It does actually have a reason that it's named that. For us, it's just VCC is positive power and VDD is negative. And in our case, they just call it ground because they are merciful. Have to nick out the score. Free candy from my neighborhood. Good luck. Yeah, have fun. Have fun. I dare you. Okay, so 555 timing circuit. That's just our pinout. We can close this. This is our schematic. We're going to build this and see where that puts us. We've got a 250 kilo ohm adjustment on the top there. So I need to find a 250K potentiometer. I might have one, although it's a little shaky because that's a very specific potentiometer. I can probably put something else in there if I really need to, but I think I might have one. I might. Since we've been doing a lot of analog synthesizer stuff, I've stocked up on some of these specialty parts. Yeah, I guess Moritz got their clock signal externally, which isn't going to help us. So we need to have our own metronome style rhythm keeper. That's 100K. These are generally what I'd use for like 1 HP things. We could adjust it with a screwdriver using these guys, and then it's not an obnoxious knob to fall off of our breadboard. Maybe I'll do that. We'll adjust rhythm with one of these guys. So we'll use these 25 turn scientific. These are really good for like tuning something, and then it keeps the tune because it's a screw drive. So the screw drive doesn't move at all when you don't move it, right? Instead of having tuning on like a knob. But we need a 250 kilo ohm one, so I don't know if I have that. Oh. So 103 is 10 with 3 zeros. So that's 10K. Oh, wait, I have a whole kit of these things. Wait, what am I doing? What am I doing? What am I doing? It's all organized and everything. Wait a second. I got a whole kit of these things. I got like tens of them. What am I thinking? Literally at arm's length. 250? No, but we can get close. That's 250. We can do 200. So that's this one. So 200K. And then I'll just put a 50 kilo ohm resistor on it. So 50 kilo ohm resistor. A big bin of through-hole resistors. Hopefully I've got the right one. When it comes to surface mount, I always have the correct part. But with through-hole stuff, it can get a little shaky. Do the LM2596 buck converters have such a trimmer pot? The adjustable ones, fixed voltage ones don't. Huh. Yeah, I mean, these are super useful in all kinds of different things. They're pretty compact, and they're a nice adjusty little thing. Okay, so we're looking for, oh God, this kit. I have not had good times with this kit of resistors that I'm looking through. But I'm looking for 250K, and then the 1K, I've got those sitting over here, so 250. Oh no, I'm looking for 50K, sorry, 50K. So 68K is right there. 82, 75, 56. So we're going to have a slightly different resistance. Well, I'm just adding that extra resistance on it. I want to get some components, but I'll probably end up with a huge mess. Yeah. Keeping stuff like this organized is a struggle. It is a worthy opponent, but it requires its own maintenance. You can see I'm not doing a great job. I really need to buy another one of those kits of through holes. My big problem is that we've moved to these precision resistors, and these precision resistors are low current, so they're thin, and so they end up making a very flimsy connection to the breadboard. So that's the 1K, and it's precision, so hopefully it won't be too much of a hassle. See, and this isn't temperature compensated or anything, so if I put this into the modular synthesizer and I used whatever BPM was coming from this circuit, it could potentially heat up inside of the enclosure and change my tempo. That's why you have TXCO, temperature compensated XO oscillator clock. Buy digital resistors. You know, you're joking, but those likely exist. So Thur and Trig get shorted together on one side of the 1 kilo ohm. Thur and Trig. And they're, of course, nowhere near each other. Wait. THR, Threz. Thur and Trig are 2 and 6. That's all the way on the other side of the chip. Dang it. $1,000 later, yeah. Will the drum kick or will the drum beep? Or will we transfer the signal to LEDs? I'm actually worried about whether this is supposed to be a metronome, so I think it just pup, 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 right, on the speaker. Unless it's I don't think it's creating like an enveloped audio wiggle, right? I don't think that's happening. We have 22 oof for C1. So Thur and Trig 6 and 2 are getting shorted together. Let me get my resistors out of the way here. And figure out what wire length I need to go all the way around this chip. That's very, very annoying of you, 555 timer. Oh, these are numbered in the schematic. Oh, that's good. 1, 2, 3, 4, 5, 6 goes to this pin over here. How do I get there? That's like the most awkward that it could be because it blocks everybody. Let's just do a little jump there. See what kind of length I've got out of this thing. This is 5, 6. Man, everything about the 555 timer is hateful. It's just a nasty chip that's filled with cruel ambitions. Just an antisocial, nasty chip. It doesn't care about you. Every single operation with this thing is just hateful. This is the stream, by the way, where I actually make a 555 timer do anything. It's finally happened. I've not been able to avoid it. And I have to actually go and get capacitors. Should I just go over top? I'm just going to go over top. The one thing that I really try not to do on these is to go over the top of a chip because it's generally kind of sloppy. But making an exception for the 555 timer so that I don't have to look at that part number on my beautiful board. Now it just looks like I'm trying to hold the chip down. It just looks like because it was so windy yesterday that I am just trying to strap the chip down. 4 and 8. Actually, 8 needs to be connected to positive. So pin 8 up to positive. That's the reset pin. Another one of these. So 4 is over here. Using my overly long jumpers because I don't have any. I need to order a kit. I need to go online and order some yumpers. So pin 4 over here goes to positive power. There we go. That's 4 and 8, and then the 250 ohm resistor connects to pin 7. Yep, pin 7. So there's a, let's see, positive power on one end. So let's use the special super duper tool. And we actually have a Thingiverse for a tool that's equivalent to this. The only thing that the Thingiverse tool doesn't counter for is the increasing bore size still being aligned with the back plate. Yeah, we're doing a little we do a little prototyping. So the 1 kilo ohm resistor goes between pin 7 and 6 or 2. So if it's going between 7 and 6, we can just bend this down, and that's going to be our 1K resistor. So clip the leads to the right length. So pins 6 and 7. What up, that your fan? How you doing? Right now, we are actually prototyping with a 555. Believe it or not, I've sunk this far today. So top 2 leads of this one are shorted. Because you are shorted. Because you are floating, and I'm going to flush your ass. Hackers the movie. Ah, damn it. That was not the intended result. So I saw K-pop Demon Hunters. It was all right. It wasn't like great. It was definitely a kid's movie. Just clock that one as having been consumed. Oh, you had family stuff? Ah, that's the worst, man. Well, I'm glad you're getting through it. Glad you're here. You don't have to be here. Finally, I've put a jumper down. Okay, so now we need to jump to positive, which is on our rail. I go in like 10 different directions at once when we do breadboarding, so bear with me. It's going to be kind of crazy until I get all this stuff situated. The blue is just a little bit long. I guess I'm going to have to like jump to the side a little bit unless I can find exactly the right. I don't have it right now. It's not in here. It's not in here. Yeah, no, none of this is short. Wait, this one shorter? No, it's longer. You always have like an idea. You don't like to use ceramic tweezers. Somebody gave me ceramic tweezers. They sent them in. And I'm not a huge fan just because I don't know the feel of these guys. Like these are okay. I guess they would do okay. But I like my metal tweezers. The worst is over. Time to enjoy the zoomed in lens. Yes. Yes, indeed. All right, so it's like I always have a length in my mind, right? In my mind's eye. In my mind's eye. I'm going like, all right, I need a length of wire. It's going to be shorter than the one that I'm looking at right now. And then you look at the jumper kit and you're like, that seems shorter no matter what. And I pull it over and it's always larger, always larger. Just a bucket of piss. This is, I think, the shortest length that I have in this entire kit. And it's too big. Yeah, I don't know why people I don't know. People seem to think that I should be using certain tools in order to do this stuff. Like, oh, ceramic tweezers so they don't conduct. It's like, why? You know, there's no voltage going into this until I build the whole circuit. And even if there is, it's like a pithy amount of voltage. So grabbing it with a ceramic tweezer is not really going to affect anything, especially in a system where you can just rake your hand over the whole thing and change all the values just capacitively. This isn't that special not conducting. I mean, these are stainless, so it's not like they're conducting heat into my hand. But it was enough of an issue that a viewer sent me tweezers. Ooh, this stuff is like, I use pine straw? But you can put it in a fire. Where are the fires? Where are the fires? Oh, this actually, before it goes to positive, I needed to go through our 50 kilo ohms. So we'll actually pull this over with a resistor. I could save space. I'll probably need to save space, considering we're not just trying to build a 555 circuit, we're actually building a drum sequencer. So I'll try to be a little bit compact. I'll pull this over a jump before bringing it to voltage. That way the blue wire can be more straight. Okay. So, positive power, 50 kilo ohms, 200 kilo ohms. Honestly, this, I could probably just put a 10 kilo ohm on there and it would be fine. I don't know. We're just trying somebody else's circuit. I think the value of this could be a little bit more malleable because we're just using it as a variable resistor that injects very little amounts of current into the DIS pin, which is pin 7, which is right here. So we just need to jump over there 4 spots. Do I have a 4-spot jumper? No. No, I don't have a 4-spot jumper. Why do you keep asking me about the 4-spot jumper? I don't have one. You just keep asking me about four position jumpers, and it's, you know, it's getting to me. It's getting to me a little bit. I'm getting a little bit ticked off. I use them all in every other project. I am out of them. Let's see, there's some dregs in this bin, but it's not looking good. I'll give you that. Bought one of those robot arms. Gotta have fun with that. Oh, that sounds awesome. Robot arms is the direction that I want Burn the Subs to go in eventually. Of course, I've always said, you know, how did O'Bother die? Oh, he was mauled to death by a robot arm that he programmed badly. That's what's going to happen to me. What? So we got to go to this. Oh, I actually had the length. It was like the last one, but I had it. But you can put it in a fire. I read that comment. That's the wrong pin. I need to go 1 pin. Really? Oh, you sons of bitches. Oh, you bastard. Cheeky bastard. And then, of course, because this is a newer breadboard, it doesn't like to take these pins in, and it'll like bend them. There we go. That's good enough for a 555. There we go. I'm going to make those resistors a little lower. I don't like how tall they are. Goes to power over here. Come on. Yeah, I guess I could have just gone for like a 500K, and then we would have had a larger dynamic range of low current source to charge the capacitor part of the circuit, but whatever. Okay, so anyway, that's that part of it. Now we need a 22 microfarad capacitor from pin 6 and 2, so from here to ground. And we can either jump the span, or I could pull it over to another area. Let's find a 22 microfarad cap. Now, this isn't, oh, this does specify it is a polar capacitor. So it's got a positive and a negative lead. So the plus is on there. Generally, the capacitor is represented by 2 plates because that's literally what we used to put in what are called Leyden jars. And to make old-timey capacitors, if you put 2 plates next to each other, charge one with electricity, there's a charge between them that builds, and then you can discharge that electricity. It's sort of like a little delay device. At time equals 0 is the very nanosecond that you turn on your device. So t is equal to 0. All your capacitors that are uncharged will act as short circuits. And so we sometimes use that to protect digital electronics from an inrush of current when you turn a device on from nothing. That's a decoupling capacitor. It decouples the device from your power supply. In this case, what we're doing is we have 250 kiloohms coming into this thing. What the 555 timer is going to do is it's going to allow that little tiny trickle from the 250 kiloohms of what is 9 volts in this. It's going to be 5 volts in our circuit, so it'll be slower because it'll be less current, V equals IR, voltage, current, and resistance. Hello, words. My name are brain. We're going to trickle that little tiny bit of voltage into the capacitor until it charges, and then it'll discharge. And so the 555 timer uses that a charge and discharge cycle in order to make the timings that it'll output on, in this case, in this circuit, a speaker. But I don't know, 555 timers are generally hateful, evil things invented by Satan. I do not condone their use, both in war and peace times. I just don't like them. I don't like doing all these calculations. So, capacitors. I got a big bin full of capacitors. Although I do also have, well, no, not ceramics. We're going to use electrolytic capacitor in this case. And then 22 microfarad is actually a timing element because there's time in the capacitor equation. Finding one is going to be kind of difficult. I think I have them. 100U. And if we get close, I guess we could probably... I clicked on one of my anti-scenes, one of the scenes that's actually just a divider between scenes so that I can know where I am on the page and stuff. And I don't know, I just dragged something. Yeah, I dragged this one to the wrong one. There we go. Jeez. Misclicking with this mouse sitting here. All right, let's see. 22 oof. Yeah, if when it comes down to surface mount, I obviously will have the part. It's in fact sitting right in front of us, but surface mount capacitors are annoying to deal with. So I'm hoping we can just find one of these jabbies. One oof, no. We might also have to adjust this because of the voltage and the voltage change, basically. That's going to influence our rhythm, our tempo quite a bit. Short time battery. We're talking like nanosecond batteries, microsecond batteries. Now there are supercapacitors. I've never had really any use for them though. I guess if I were still like, if I were going to do a car project and it would use an internal combustion engine, I wonder if I could put a supercapacitor and like a lithium ion battery and have that start up the starter motor on the car. I think somebody made a battery out of their supercapacitors. Samsung's using it in the S Pen. I suspect that they're used in those digital thermometers too. You don't necessarily want to have a lithium-ion battery in your food in one of these digital thermometers. So I wonder. Although it charges much slower than a capacitor, so maybe not. 100 off. Come on, man. Where's my... What I really should do is take little strips of cardboard and glue these, not glue these, tape these to the little strips of cardboard so I could look through my supply of capacitors and immediately know whether or not I have 22 oof and what size it is and what it looks like. Because this one is 33? 3.3. 22 versus 3.3. Not quite. Not my tempo. One. I could get 22 of these. That's 220. I need 20. Capacitors have a voltage rating and then a farad rating. Between the voltage and the farads, you can figure out what your timing is going to be. The voltage, however, is a tolerance. So when they say that they are like 100 volts, like this one is 58, tolerant of 50 volts. I would not want to put this one on a 50 volt circuit. I would put it on something like a 25 volt circuit with ease. Give it that little buffer zone. 47. It's gotta be a 22. It's gotta be a 22. It's gotta be a 22. Otherwise, I'm gonna have to go into 220. I'm gonna have to go into equations, recalculate the value of all this stuff, all this stupid stuff. 100. I have everything but the right value, huh? Stupid big capacitor. 1,000. I thought I saw a 2.2 in these guys. That's a 3.3. That's a close enough. Maybe we'll take that one. That'll slow it down for the different voltage. Yeah, we're gonna go with 3.3. Okay, so we're using 3.3 on for cap. Our dreaded capacitor. And so that's gonna go between ground and pin 6 or 2. So pin 2 or 6. Pin 5 is float. Pin 1 is ground. Pin 3 is our output. This is our output right here. So between this and ground, I guess we could just do it this way. So I'll just bend my lead out and down. So we have just a smart little cap sitting on the end here. So that was just doing this. And then I'll just go right here. And then this board is not linked from side to side. So I'm going to have to run 2 wires on the outside, around the outside, around the outside. I'll make them out of blue wire. I'll just strip this. So this goes down. And then it goes across. And it goes to plus. Ooh, that didn't bend very good. That's all right. I always take these for granted. Granted? Granite? You take things for granted, not granite. Although, granite is pretty... Actually, granite's not really that cheap, is it? This day and age. I took you for granted, granite, and then I valued you pretty highly for something that people generally think is a given. For people who know about buying rocks. Wire stripper. Oh, this guy's building a drum machine. Look at this stream. I'm sitting here with a 555 timer. My arch rival. Got to make 2 of these little jumpies. Just so that when I plug in power, all of my rails will then go to the right voltages. Down like that. I'm just hearing wind outside. There's just wind blowing noises. My neighbor's corgi was out on the porch. They have a little like balcony, and the dog was out, but he was barking at the door. He was like, "Let me back in. This sucks." He's Willow's early warning system if somebody's coming up the street. So Willow will hear the dog barking on the balcony, and then she'll want to run into the intersection to see who's coming up the way. Okay, there's my rail connectors. So from minus to minus, make sure to get that right. Minus to minus, plus to plus. Don't want to do minus to plus again. Not again, not after the accident. This thing does not want to sink into the actual, like, clip that's in this thing. Maybe if I do this, it'll get along a little better. If you're using, like, these thin wire resistors that I have, sometimes they'll go in at a weird angle and they'll miss the clip entirely, and then it won't be a connection, even though it looks like a connection, which is when the prototyping, the solderless breadboard lies to you. It's really quite a betrayal. That is just not cooperating. What is going on with that hole? Let's get a pin tool on that. A really small pin tool. Yeah, this is a good one. Just a pin tool. Let's go in here with this. Oh yeah, something's wrong with that one. Whoa. That did not feel right. Yeah, there's something wrong with that one. I'm going to have to jump over to here, I guess. But our circuit's already over there. Maybe I can just skip 2. Go to the second clip in line. Yeah, that'll do. Just had to skip 2 here because that one is like genuinely messed up. All right, grab this +1. +2 plus. There we go. All right. Ta-da. And now we ignore that these are over here. All right, so now we need 5 volts because this stuff is 5-volt logic. Oh, and I need a an LED. I need an LED. So I guess I'll either find a singular LED or we could use one of the gangs of LEDs that I put together. Where are my gangs of LEDs? There we go. So we'll use these. These have resistors on them already, so I just put a bunch of, it's the like clown balloons, but I put a bunch of them together just so. Mark it so you know in the future. Then I'll be like, why is there a mark on this? No, if this is gonna stay like this, I should presumably I would avoid it. I actually want to find one of my dedicated yumpers. Where are my dedicated yumpers? I have usually I got stuff like LEDs sitting around that are all wired up already with a resistor. I think those made it to the other breadboard setup, didn't they? I don't think they ended up. Oh, you know where they go? Yeah. We've got a bin that's full of old breadboarded stuff in here somewhere. I just need to find it. There we go. Old breadboard stuff, and in there I've got, just an orange LED. Perfect. LEDs are really going to be our go-to for this project, because that way we don't have to listen to thud, thud, thud for like 50 minutes. I don't know how my boys who do music production stuff tolerate it, but they will sit and they will listen to thud, thud, thud with zero variety, I guess. I don't know, zero, you know, no change in the music for hours. They'll just listen to it. So this goes to, the speaker goes from pin 3 to negative, which means the toilet bowl of the LED, because LEDs have a toilet bowl in them nowadays. That is a toilet bowl. It's also the reflector, but it looks more like a potty to me. This is negative. So this lead is negative here. So that goes to here. And then this goes to positive. And I've just got, I think, a 1K kilo ohm resistor on this to make sure that the LED does not blast our retina out the back of our skull. Because if you do the exact calculation on the LED, you can find out how much current the LED has, how much forward resistance it has. You can calculate out the current V equals IR. It's all very well and good and easy and simple. However, oh, why did that power down? Weird. However, when you put it into your bench, it'll blast your retina out the back of your head because you're running the maximum current for the LED. So instead, we just use a standard, easy to find current limiting resistor, 1 kilo ohm. Generally, if you calculate it out, it'll be like 330 ohms is what you would be putting on it. So 1,000 is not that big of a departure, and it keeps this thing from blowing up your face. I'm going to switch to an audio reactive one here. Something like rattled the circuit board and disconnected it. Frequency pixels. Yeah, that one's pretty good. Sparkly. This one's nice and sparkly. Sparkles. Okay, so the power supply is not connected right now on this project, on the LED project. So we'll bring it over here. I am going to power it up. I'm going to set it to 5 volts. Once it, you know, powers up at all. Come on, buddy. There you go. So we are at 4.2 because this is a battery operated project. Now we're at 5. Okay. Turn power on. And then I need to get 2 jumpers that'll be positive and negative into the breadboard. Luckily I got all this crap sitting right here. This is where I would have us do like a prediction on the channel. And you guys could bet channel points to see whether or not I actually power this thing up or if it explodes. But I am just going to hook it up because this is a 555 circuit. There's not a whole lot to this. Sure, actually in focus. And oh, this is loose. Everything's always loose. Why is this always so loose? Consider Loctiting it, but... All right, so what we should see is this LED right here should blink on and off at a particular rate. And then when I adjust this resistor over here, that rate will change. So ground to ground, power to power, and it's on solid. And it's on solid. Capacitor is connected on the ground pin. I didn't actually check to see that I connected the ground pin to ground. We got lucky with this capacitor. I hooked it up right, I think. So let's try changing the rate by screwing the screwdriver on the variable resistor potentiometer. Could be that we're oscillating very quickly. Well, it could be that we're oscillating very slowly. All right, that's one end of it. Go to the other end. Yeah, so cool. Nothing ever works. Double check. Five volts through the resistor, which is 50K, onto the 200K, goes to pin thingy-majig. Pin 7. So pin 8 is positive. Oh, wait a minute. Okay. So we've already got a problem. 1K because goes between pin 7 and 2, not 7 and 8. 8 doesn't get this resistor. And pin 2 is also pin 6. So 6 and 7 get the resistor on it. That did not affect the results. So 7 and 6 connected together with a 1 kilo ohm resistor. 6 is also connected to pin 2. At pin 6 and 2, with the 1K resistor, we have the positive lead for the capacitor, which is 22 microfarads, in our case 3.3. Oh, it's not anywhere near 22. Okay, so we need a much larger capacitor than what I have. That was the problem. Did it say, it's a drum, it said drum, I didn't make that typo. What's up, Casper Poland? Yeah, I don't. The amount of time between now and when we make music is going to be kind of significant. 22 to 47. That's doubling the value. Could probably make that work. I can't really find a 22 though. That's the problem. 3.3 is what we had. That does not. That is certified that it does not work. We just tested it. You guys are learning why I hate 555 timers. These things suck. They suck. You're terrible. It can't be this big chonky boy. No way. 100. Capacitors are weird. They all have these weird values. They'll differ from each other so much. $220. That's an entire order of magnitude off. That's the one we were just using. Come on, 22. One singular off. Yeah. One F. That was a precision one. That was a nice one. $6.8. Ah, not even close. We need 20. Somewhere in the ballpark of 20. Yeah, I don't think I'm gonna find it. So we'll just use 47 because it's close enough to 20. All the values are all squiggly. Between not positive, we want ground and the resistor there, and then it flashes, and then it flashes, and then it flashes, and then it slow it up. The speaker goes from output to ground on pin 3, so this is our speaker. And we have an equivalent of 250 kilo ohms here. So that should have slowed it up enough that it should be doing tempo stuff. Was that it flashing? Was that just me? I think that was me touching the capacitor. Yeah. It's just, well, we might actually be getting some movement of this thing. Oh, maybe it's because this lead isn't. Ah, there we go. So there's our plip. 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 All right. Maybe we're almost there. I'm not sure. It's clicking on that end. What if I take it all the way to the other end? Is that going to slow it up or speed it? I think it's getting shorter. Could I bother you maybe to just give me a little bit of timing? Ay, ay, ay. This is annoying. So that's yeah, 1K between is the value of the resistor that goes between the two pins. There's the discharge resistor right there. We're kind of getting like the opposite of what I want. I don't know if I should take it to positive. Bup. 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 I hate 555s. I hate them so much. All right, let's speed this up. I kind of want bup, bup, bup. 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 See, we've got basically a 50K resistor on this thing fixed. So if I just get rid of that resistor, I can make it go faster. Okay, that just made the whole thing not do nothing. There we go. Bup, 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 bup. Bup, 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 bup. There we go. Bup, 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 bup. You guys are sick of me making the bup noise. you're in the very beginnings of a lot of me going, but what's up, Short Lurker? How you doing? Short Lurker, I failed you. I failed you. It's a 555 timer under that wire. You put a 555 in it, didn't you? Oh. I have electrocuted myself 0 times. I have never electrocuted myself because in the definition of electrocute, it's kill. This says injure or kill by Electric Shop, which, fine, injure I have done many, many times, but really this definition is too wishy-washy. Electrocute means to kill. That's the cute part of it. That's why it's so cute. I shock myself all the time. I don't really have any good recent ones, though. There was one time I thought that I could rewire a light switch without turning anything off. That did not work out. The second I touched a screwdriver to it, I felt a very strong buzz, 60 hertz buzz. So what's going on inside of the circuit right now is the 555 timer is a total piece of shit. And what it does is it discharges and charges this capacitor utilizing the resistor that you give it. So the resistor and the capacitor combination are charging and discharging and giving a timing element to the output over here. Could we have done that with the transistor? Yes. Would it have been more of a pain in the ass? Yes. Why are we bringing in a 555 timer? Yes. The reason that we're doing it is because we are going to be counting things. In order to sequence drums, you need to have a rhythm to start with. So this is going to be our BPM. That's not so bad. And now we can get into the slightly more complicated matters of actually counting the timings. So in order to count the timings, what Moritz Klein did and what I'm going to did involves always a good freeze frame. Always a good freeze frame. I'm trying to get to the part where he's not shading out stuff. How do you discharge capacitors? So if you're on like a battery operated device or sorry, hold on one sec. I have specific advice for this. I'm just trying to get to the schematic that YouTube keeps telling me that I'm clicking on. Oh, look at your cursor's over this spot. This is definitely what the video looks like at that point. Just get this. There, jeez. Okay, anyway, it depends on the device you're working on. If you are going to like work on your computer and you want to make sure that these capacitors inside the computer are just discharged, when you unplug the device, you can wait 5 minutes or unplug the device and then on, and you got to get this right. You got to be careful, comfortable, and generally speaking, I should not be giving any advice about stuff you plug into the wall, just so that I'm not liable in any way for the advice that I give. There are electronics forums that don't let you talk about anything like that. But if you get like a insulated screwdriver and the leads that go into the device, when it's unpowered and unplugged, gotta be sure that it's unplugged, you short the leads that go into the device. You do not short the leads on the power plug or the wall socket or anything like that. It's the device itself. You're just making sure that both of those are at low potential. But generally speaking, like with like a computer or a complicated device like that, they will have things in there to mitigate the high voltage of the capacitors. In like a power supply, you will have a discharge capacitor that is specifically, it's like a high kilo ohm capacitor that just sits, or a high kilo ohm resistor that sits between the leads of the cap so that when you unplug it, it'll discharge through that relatively fast. Other than that, there are times where either I'll just wait or I will ruin a screwdriver potentially and like manually short them out. I wouldn't suggest you do that because those capacitors dump everything in like a millisecond. Some people have a leaded resistor that's insulated that they can put on the 2 leads of the cap and just hold it there for a second and then it's done. The resistor keeps it from sparking when you short it out. What up, Plus Master? Whatever you're prototyping here, will you be creating an actual circuit board like from PC? All right, listen, I'm not sponsored. I don't have sponsors, so we're not going to sit here and go, our PCB way, the best way to blah, blah, blah. I'm not going to give them free. They can pay me. They can pay me a big chunk per hour to advertise their service. Those are sponsor deals are awesome. I wish I got one. I like using Seed Studio, but they are in China, and so our tariff craziness continues, and I am reluctant to order stuff. I don't think it affects us, but who knows? Because every day the stupidest thing happens. So reconciling with that, I'm not going to see myself jumping out and ordering PCBs. It kind of killed the mixer project, the modular mixer project. I'm kind of shelving for a little bit. The next thing with that modular mixer project is that I need to order some of those vacuum tubes that Korg uses. They worked with Noritake Itron, who makes vacuum fluorescent displays. And instead of having a vacuum fluorescent display, they use their sort of wafer thin technology to make a lower voltage, I think a lower current version of vacuum tube, which I would love to use in the mixer. That would make the mixer very, very truly special. I might need 2 of them though. So we made a thing do a thing. Now we need to make a thing count a thing. So our rhythm section originating from over here and going into the counter, is that going into or coming from? Well, we have down here with the counter, we can zoom in using the special technology of the home computer. We have a CD4520. So let's plug in a CD4520 and we can use a couple LEDs to watch it count my pulses. But because we're not Moritz Klein, we do not have the Moritz Klein parts. We have the Obother parts, which are 7400 series logic. So we are working in 5 volts and we are working with weird, strange things. So this is an SN, now here's the important number, 74 something something 691. Nice. The 7400 series is legendary in electronics. They are 5 volt logic, and they do all those logic things. Now here, we have a bit of a confusion on the markings here. Not only do we have a dot, we have a trough. Now, considering that this stuff started as vacuum tubes, I'm assuming, well, actually, we're just gonna have to look it up. We're gonna have to see what Texas Instruments says about it. 74LS691, why would it be the opposite of the 555? Wonder how accurate the integrated circuit is when it comes to counting pulses. Well, it depends on how many bits you have outputting, but the logic stuff is accurate. I don't know, like a microcontroller, how accurate. These are good up to like, what was it, 60 kilohertz or something? They're not doing radio speed signals, right? But the thing is, like with the logic chips, everything is pretty much instant. So anyway, we need to look up this specific part, which is not you. CD45. Okay, so that's not the one that I'm looking for. This is a 691. SN74LS691. I want that whole specific part number, and I want it to be from Texas Instruments so that we know what our pinout is in case they change stuff. Maybe we'll just look at it from Advanced Micro Devices. Why does DigiKey have a splash screen? So this is an 8-bit up-down counter, not a dual 4-bit counter. Although I guess we don't need the second counter. Very confusing. I ordered Raspberry Pi size PCBs from JLC a couple weeks ago. It cost $1.20 in tariffs. I thought it was supposed to be for stuff that's under a certain amount of money. It was not. What up, Agelos? Agelos? Agelos sounds like a planetary computer system from Star Trek. Like a 1,000-year-old planetary computer system where it's got like a console, and then it's just one of those original series famous crystals that just lights up whenever you're talking. It is me, Agelos. I predict rain. Okay, so 8-bit up-down counter. Up-dog counter, sorry. And we've got all of this ridiculous crap going into it for counting. So what are we counting? We have a clock pulse coming in, and our clock pulse goes into on the Moritz Klein circuit. going into CB because I think this thing has a clock that's specifically supposed to be going in there. There's a clock going into pin 1 though, and pin 24 is VCC. I don't know which pin is pin 1 because there are 2 symbols on this thing. Now, if I went by the orientation of the text, okay, so this is pin 1. Oh, that's the 469 that I'm looking at? Crap. Okay, so hold on. We'll pull up the correct data sheet. That's like step 1. 9-1. I think I got fixated on the 6-9 of it all. Cost us under $10, so adding $1 wasn't a big deal, but still adding 10% or more is still kind of crazy. The $5 PCBs become the $6 PCBs, and I don't like it. That's weird. The DigiKey pulled up the wrong one, probably the same thing, but the wrong one. It's funny, these parts, the 7400 series, just barely made it into surface mount. Every now and then you find one of these ancient chips running something. The controller was a particularly surprising one to me. Application notes. That didn't even have a datasheet. Stupid. 66691. There we go. Like, I bought the, what is it called? It's that David Bowie-ass instrument that's sitting over there, the little touch, like, keyboard thing. We took it apart and it was a 555. I expected something like a, like an epoxy top on it. Why is this player bad? I had this datasheet open, didn't I? I have this open somewhere. I must have closed it. I would very much like to just see the datasheet, please. Oh my God. Why is this stupid? Is this like a specific, or is this a Firefox thing? Whatever, so we got, all right. No. That didn't do anything. That just went to a different page. It's like watching your grandpa use a computer. All right, 691, shelf life of 12 months. 74LS691. Wow, that's... Do you have a data sheet, maybe? No? Okay, hold on. Shipping carriers, if they decided to tack on or double up the fee. Yeah. I guess I could have clicked the download one. Sometimes it just opens it up directly from... Boop. There we go. That's what I was looking for. That's a little bit easier to use. Okay. Pin 1 is clock clear, so I guess I have to attach that to VCC. Enter, load, acknowledge, ground is over there. Okay, so let's hit the ground running on this, and let me get it connected to power. I guess I should probably power off for just the initial connecting of this thing, just to be nice. So pin 1 is clock clear, and so I guess I want to connect that over to power. And then, of course, my jumper situation is abysmal. So we're going to be kind of fishing around for jumpers here. We're going to have anything but the right length. Anything but the right length on these things. I want to at least get something counting, and then we can come back to this project, because the next stream, which is going to be Tuesday. The day after my birthday. I'm going to get born. But that's, yeah, when we come back. So pin 1 on this one is clear. Do we, well, it's active low, so putting it like this deactivates clear. So that should be fine. Pin 20 over here is VCC. The CC. VCC. Consider yourself VCC'd. You gotta kind of fish in these to find the clip, otherwise it like jams it into the side. Okay, next is ground. Ground is pin 10, which is the end of the row. It's a 20 pin chip. Good. There's like no room over here. Great, just what I want. Will this jump the jump? Walk the walk, so to speak. Talk the talk. Oh, it would, but that's on the blank. Oh no, actually we could go right here. Yeah, that'll do. Oh, but then because the clip isn't separated properly, it ends up bending the crap out of my lead almost immediately. Just wonderful. Just wonderful. Love breadboarding. Love it. Love it. Technically, you should decouple these, but I don't really think they need decoupling in this scenario. Weird stuff could potentially happen. Somewhat of a VDD myself. I'm something of a VSS myself, Peter. Okay, so R clear load. What do we need to do with R clear and load? Let's look at their test setup. Oh my God, there's a lot going on here. Good Lord. Okay, well, you guys have it. They don't have a test setup. Whew. 7 volts. Wait, what? No, we were TTL. No, I don't have a 590. The higher numbers kind of skip around. So I have lower number 7400 series logic chips. 590. I don't think so. $154, $373, and then we jump up to like 600 after that. Yeah, 374, and then we jump up to like 600. 536. I don't think it's going to be this small. 279. Nah. That William Dafoe clip, Spider-Man one will forever live in my brain. Yeah. There's a lot of parallel functionality in a lot of these things, so we can definitely find. This one is, you're looking for 93. I thought I saw a 93. Or are we using a... No, we're using a 91, which means where the blank chip is around where we want to be looking, so it's somewhere around here. No, that's 245. We got to go down to 90. 161. That should be close. 227. 151. 38. Oh, wait, 125. 130. So we're way too high. 75. That's 112. So it's smaller than that. 93. That is an old chip. 74LS593. Wait. 593. No, LS93. No 5. No 5. No 5. You're the 5. Okay, let's look up 74LS93. 93 is 4-bit. Yeah, and I think we're only using 4 bits. 74LS93. Four-bit binary counter. Yeah, that might be exactly what we need. I think so. Good call. Good call. Decade divide by 12 in binary counters data sheet. So we're multi-data sheeting this. 74LS93A, etc., or W package, and so clock B, clock A, and then no connect, no connect, no connect, Q, A, B, C, D, blah, 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 blah. What is the operation? Oh my God. What the hell? These logic diagrams are crazy. I never dealt with these. Two and three into an and. So these are a way to describe the logic of a chip in the different blocks of functionality. So here we have pins 2 and 3. I'm not quite sure, you know, 1, 2 going in there. I don't know. I don't quite know what's going on there, but it's ANDed together, and then count is equal to 0. 2 and 8 divider. Ah, man, these are weird. These are weird. I put all my random ICs into a free account on Partsbox so I can look up what I have. That's kind of an interesting way. I never thought to do that, and then you've got to keep your stuff updated, and I would never keep my stuff updated. Q0 back to clock B, and we're all set. All right, let's check this out. Let's check this out, because the Moritz Klein video I had on in the background, and I was like, this is an amazing video, and I want to do right by it and actually like make something drum machine-y, because the sounds that Moritz's drum machine was making are amazing. Moritz, I don't know what their role is in Erica synths, but they do some amazing videos on their own YouTube channel. He does, I guess. Absolutely awesome stuff. And so it's this breakdown of what all the decisions were in putting this thing together, and he keeps it just complicated enough not to bury the lead. I think he's actually a brilliant engineer. Engineers that can communicate are something extremely special and important, and many of us have been kind of steamrolled by the industry. I can give a presentation to many, many different people, and I can figure out how a circuit works. And I can talk about things simply. I've just never been trusted in any of those roles beyond, well, I've had some pretty good experience doing that kind of stuff. But how should one prepare for embedded systems coming from computer science? I already have some experience with MCUs like the Arduino. Yeah, I don't know. Why did this die again? Why'd you die? Are your leads getting shorted? Why did you did? You know, industry now and industry when I went off and did my own thing are very different. Things are very different these days. Oh, my little sound reacted. Oh, wait, we're back. Oh, it never went anywhere. It just wasn't loud enough. This should be pretty sensitive. Change program. I don't really know what's going on over there. Industry is way different. I'm going to unplug the audio reactive thing. It's not bright enough right now, and yeah, we got to figure out how to put that whole circuit into this little box. But anyway, I'm not too in the know about what industry is like these days. Preparing for embedded, I don't even know where to go with that. I'm old, that's why I know a lot about the 74LS series. You can tell the old guys because they know the numbers of the 7400 series by heart. I was never quite that era. I'm a little bit beyond the 7400s being totally relevant, but this is how we used to do stuff. This is how we used to make circuits that do smart things, especially industrially, is by having things like counters and decimal decoders and things like that in order to produce something when things happen. Just whatever. But an amazing thing about it is that you can produce some very complicated setups that don't have any software in it, because everything's just happening as a series of events through things like counters and triggers and things. Cool stuff. It's cool stuff. It's cool stuff to reflect back on. I can't imagine how stressful it would be to have to implement in the real world. Having a lot of trouble with this one. I'm feeling bad things are going to happen soon. I'm going to slip up and this will blow up. I'm part-time unemployed, let's put it that way. And I theoretically would still be doing consulting if I had clients. Okay, this is getting frustrating because I'm going to overdo it and fold an entire row of these pins in on itself. There we go. The rolling on the table technique is generally how I fix these. People could buy tools. You could buy tools that have like a little pin fixer in it. Don't break it. You have only one. I have three. I clocked 3 of these. I've done it in the past where you're trying to roll the chip and it just collapses on itself. It is very annoying. Okay, so our pin out. We are the 93. So that's this one here. B and A, no collection. Q, pin 10 is ground. That's a weird one. VCC is 5 and 10. Okay. So we can get rid of this one here. That would be a bad joke. And actually, where's our output? QA, QD, QB. So QA, B, C, and D are down here. Let's see if they are going to be in that location, because I'm going to want to put LEDs on this, and those will go to ground, I guess. So I'm actually going to move this up a little bit. Every time I move this, I risk bending all the pins. So ground is the toilet bowl. So we'll put this is designed for this sort of thing. Put this right here. I don't like, one of the pins skips, so it's going to be A, B, my ground pin. Well, A, D, B, C. All right, I'm just going to move this out and we'll just use jumpers. Yeah, it's kind of annoying that they are, but we'll just jump it over. Because that way I can represent them in a row of pins and it'll look a little bit more accessible, but they really did scramble this one up, didn't they? This is getting so annoying. Can you please just go in? Just, cheeky little, oh my God, okay. Father's starting to lose cool. It's like just a little bit. But you got to be so careful. I could do this one facing this way, and then my pins here would be the outputs, but I think I'm just going to do it in the same orientation as everybody else. So pin 1 to the right, and that way I don't have to double check every single time I do something. So we'll just do it just like its buddy was. And then the pin that is ground is probably going to be the one that's blocked off. What is it? Pin 10. 1, 2, 3, 4, 5, 6, 7. Wait, that's not right. 14, 13, 12, 11, 10. Oh, 14, 13, 12, 11, 10. So this one's ground. Oh, it's right in line. Perfect. So ground here. LEDs up here. That's getting a little close. Maybe I should, because the outputs are going to be here. So I'll do this to ground. And now we can have the counting bits come over and up. Would be a lot more convenient if I flip this around, but I'm not going to do this. This chip hates you. Yeah, it really does. Okay, so that's ground. VCC's pin 5. 1, 2, 3, 4, 5. I'm an engineer. I can count. Okay, pin 5, and then R0, 1, and 2. Two and 3 also go to ground. Those are R0. There's an A clock and a B clock into this one. This shouldn't be dual. Gated 0 reset and the 90A LS90 gated set to 9 inputs. To use the maximum count length, clock B input is connected to QA output. Input pulse are applied to CKA. Oh, so those aren't what I thought they were. R0. So CKA is what I want to send my pulse into. So clock A. And clock A is pin, it's this one all the way over here, 14. So our pulse goes from here to here and crosses the whole chip. That's annoying. I could do it with like a big loud above jumper. Floating pins are 1, 2, and 3 are reset for zeroing. Okay. Oh, reset to 0, R0. I get it. I get it. I get it. I get it. I get things. All right, so let's just get a big bendy wire here. I just want to see this thing counting. That's what I want to see. I could go through the tunnel, but we're not trying to win any awards here. Ugh, like blocks everything. I don't like that. So, okay, is there like a 7493 bop 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 bop. Where's like a simple setup that I can use? What is that? Clock A and B, and then QA to clock B. Okay, so QA to clock B. QA is pin something or other. 12? What is this? What is this? 1, 2, 14, 13, 12. And then QA is pin, or clock B is pin 1. Why do they do this cross-chip crap? It drives me nuts. So now I got to cross over the entire chip in order to realize their vision. Keep making me do this. Keep making me cross over the chip. Where are my tweezers? Okay, they're there. I'm getting belligerent. So it's pin 1 and pin 12, 14, 13, 12. So I got to get over to here. Is it going to reach? 14, 13, 12. We'll do it sloppy. I hate crossing over the chips like this. It's like digital's better. Digital's way better. You have to do this crap. So that's QA and 12. I'm going to also connect QA to the first LED. So this is going to get real bad real fast. It's A, B, C, and D because we're a 4-bit counter. So D is on pin 11, which is this pin here. D is going over to there. There's going to be just a lot going on here. Just a lot of jumpery stuff is going to happen. So it's A, B, C, D. I've got a 5th one on this. So there's D to pin 11. Make sure that's actually connected. This is going to look weird. Yeah, the jumpy pin out. I wonder who's responsible for that. Whether it's a chip designer or an actual person. QC is pin 8. So, oh, I actually connected it to pin 9. This is supposed to be 11. And then pin 8's here. That'll go to the next one. So I guess that's a good length. Pin 9 is actually QB. Okay, I don't want to get that. QB. This one's goes to B. Next one down is Wait, 10, 9, 8. Did I get that right? Wait a sec. 7, 7, 14, 13, 12. Oh, that was pin 12. It was 11. So pin 11 is actually D. So these are not in the right place. This is how I die. This is how I always die doing these is miscounts on things. Assuming something is a certain number of pins when it's a different number. That kind of thing. So let's start from the top. D is 11. This is pin 12, so D goes to here. I can get that to plug properly. Now I need a longer length, and I think this is in that in-between length where I can't find it. This one might work. So QC is pin 8. So 14, 13, 12, 11. 14, 13, 12, 11, 10, 9, 8. Okay. All the way over to this, which I can't get to with this jumper, because this jumper is too small. Hey. I need an in-between size. Yeah, you guys will see. You guys will see when I'm done hooking this thing up. It'll light up like the night sky. And you'll all go, "Oh my God, it's amazing." You'll see. You'll all see. I'll show you. All right, I have to do custom lengths on these. Looks great and aligned. Ugh. I like my clean digital jumper setups. You know, something to be said for that. When I'm breadboarding and it's all digital and everything's just a couple straight lines connecting everybody else. We live in a society. All right, that one's a little bit long, but it does do the job. So that was D and C. C is pin 8. B is 9. So we got to go from here over to here now. Do we? I don't know. I don't know. Some people go by the philosophy is as long as the electrons get there, that's all that matters. I like things to be pretty because then I can troubleshoot them more easily. Okay, so this one's going to be way too long, but I'm making these custom, so they're just going to be the wrong lengths. Least of my worries right now. And then finally, this one goes to here. It is all messed up. It's all over the place. No, you're out of line. You're out of line. So what this will do is this will count up on the LEDs, and then when it reaches the last number, it should reset back to 0, I think. Oh, but this has RO2 and RO1 connected using a logic gate, so they're using an AND gate on it. But it looks like, wait, binary counter. What are they doing? They got weird logic going into it in order to reset it in this example that I pulled up. I think that might be just a little bit much. This is kind of what we want. So RO1 and 2 we are connecting to ground, which is pins 2 and 3. So pins 2 and 3 are connected to ground. We should be able to get up and running with this pretty fast. It's just I don't understand what I'm doing. I don't know the chips at all. I haven't been able to read up on them, and we kind of jumped around using different chips. So if I could just find one of those one position jumpers that are everywhere, here they are. So pins 2 and 3. Damn it. I don't chase the look anymore. It goes away with age. I appreciate a nice, neat organized breadboard setup because I've had to troubleshoot some pretty foul ones. And especially in a lab or a shop where you want to actually be able to troubleshoot things, you're gonna have to come back to it after a while. I like everything to have a sense and a flow. So this is absolutely unacceptable, but I am going to live with it right now. Otherwise I will become a mess. I'll be a wreck. I guess I could have done horizontal jumpers if I had enough and moved this down here because it's still taking up that amount of room. I might as well move it. I'll if I really care, I'll fix it later. Okay, so 2 and 3 end ground. So I need to jump from here to here. That should be relatively easy to do. I should be able to do that. I can't. It's too hard. It's too difficult. I can't do it. I just can't. I can't live with myself. Oh my God, am I jumping over it? I really am. Or I need to move the jumper. Maybe the wire colors don't correspond to the LED colors. It would if I was making my own wires, which is that's a smart way to do it. People have just this kind of like solid core wire sitting around. You're doing great. Listen, when I joke like that, I'm not actually depressed. That in. God, this is annoying. The most annoying part about doing this today is that my jumper supply is just not what it used to be. Red to green, green to blue. Yeah, the clown balloons indicator setup is it's malleable. I could do that, but anyway. So all right. So we've got our clock pulses coming from the other thing. I think I've got this all set up except for my clock input. And we've got our clock A and B. This is an animated GIF. What the hell? I just watched their mouse, the mouse move on the, I'm like following the schematic and it's changing. Oh my God. So this goes into clock A. And then I think we're good to turn this thing on. Actually, let's take a jumper on that one. So we'll take a jumper. This thing will not move out more, will it? Let's try to make that a little closer. Jeez. What? Really? Doing this on a new breadboard is also fairly annoying because what it's doing is each one of these clips is fighting me. If I go into this slightly wrong, it will steer the lead into a place where it bumps into stuff. So clock B is pin 1. Clock A is pin 14. Pin 14 connected to pin 12. Oh, no, we could do it that way too. Okay, you know what? No more crossover, stupid crossover pipes. Get out of here. So this is where our clock is going in. We'll use clock B, and then clock A is going between pins 12 and 14. So I got a jumper for that. Shit. Now I don't have a jumper for it. I just sent it into low Earth orbit. These tweezers don't like round things. Yeah, it would be nice if I had, or just a color uniform jumper. But having the color-coded jumpers, if they are actually coded, which these kind of aren't, is helpful. Okay, so theoretically what should happen now is when I turn this thing on, we should get 4 bits counting here. So let's turn it on. So ground to ground. And I'll bring you guys up here so we can just see it from above. We can see more of it too. 3, 2, 1, go. Well, not exactly what I expected. Burp, burp, burp. This is like settling in. bop, bop, bop. But then why does that light up like that? That's weird. And that is 14 and 12 connected together. That doesn't quite look right, does it? One, zero, 1, 0. So 14 is clock 2. And we're connecting that to QA, which is that, yeah, that's QA is connected to the clock. And we're not getting the output that, oh, because this is connected to positive. Wait a minute. Oh, no, it isn't. That's on negative. No, that's connected to negative. VCC going in there. And we're not doing anything with any of these additional pins. So supposedly this is working the way that it should. Pin 1, yeah, pin 1 is our clock in. Clock B is pin 1. Yeah, I'm following this. So clock B is, oh, okay, wait. 14 is where we're, okay, so we had it configured correctly the first time with the weird pin. So I need to take this out. That was, no wait, pin 1 goes here, not pin 14. Damn it. Gotta do the crossover. So instead, our clock goes in here. And then this connects to this. Close, not quite. I think it might not like the clock being like this. Maybe I need to put it through something in order to create, because this is pulling down in order to activate the LED. So I may need to like invert that. Well, fine, by definition, I mean, it should be going doot, doot, doot. Are these just not connected? No, my between LEDs aren't doing... First and last bits are counting, but not the center. Oh, my butt. Gotta stand up. I think it's the clock's maybe inverted. I think that might be what's going on here. But it should still be, I mean, what? Maybe I gotta look at the data sheets and stuff a little bit more. What is Moritz doing in his circuit? Probably similar. Clock comes into clock B. Clock A is connected to ground. So what if I ground clock A instead of connecting it to... Oh, but then I see. So EB is connected to V plus, and then the outputs 1, 2, and 3. Yeah, clock A is over here, and then he's got slightly different. The 4520 is a slightly different setup, so slightly different setup. We got to figure out how to use ours in that manner. QA goes over to clock B, and then 14 is the clock input. 2 and 3 go to ground. Yeah, that's all. That's what I got. So 2 and 3 go to ground. That's pin 1 right here. Pin 1 is clock B, and that connects to pin 12. So 14, 13, 12, that is connected. QAs through whatever, A, B, C, and D, I've got connected to LEDs. But something's up. Why are we asking me about soap? I use Dove. But usually I just wash my hair and then everything else figures out what it's doing. Everything else just figures it out. As far as I can tell, this is connected sloppily but properly, which is words to live by. But I'm not seeing a sequence of counting going on here. I'm just seeing crazy go nuts. This is a 74 LS93. This thing is going to be running at the speed of our beat in order to give us something to activate. Well, it's basically pushing things through our serial to parallel chip in order to create a sequence of rhythm things. But I'm having a little trouble with this right now. That should work. That should totally work. I think it's because of the inversion of the... what happens if I disconnect the LED? It does the same thing. See, the LED here I have going to positive. So this is actually pulling it down. It feels like maybe I need to invert this somehow. What's coming out of the 555. So that it is a positive clock pulse instead of a negative. This is annoying. This thing just refuses to go into that cleanly. Yeah, all right, I guess I'm just going to have to think about it a little bit and mess with the circuit more. Use the LED to test A, B, C, and D on the chip. Well, no, this wouldn't be inverted because of that. That's so weird. Everything appears to be connected exactly right. It's just not counting. Maybe this is damaged. I don't think it is, but let's see. I can use this LED over here to test it. So going to positive to that pin. It's solid and it's unwavering. So that means it's pulled low. Let's try this one over here. Now that one's flashing with its buddies. Wait a minute. Oh, that one might not be working. All right, let's see. I wanted to have this reorder the LEDs so that they were in sequence, but let's just hook them up again. Here, I'm gonna do this solid and move this over to the gap. And then connect ground with a ground jumper question mark. Power down for now. Let's see, I need a shorty little jumper. Little guy. That's too long. The jumper situation is getting abysmal out here. It's not that I don't have jumpers, it's just that the specific lengths that will wire up a board like this are just gone because I've wired up a bunch of boards like this. Used to have this giant breadboard setup that it existed on this slanted front. We looked it up. I can get one for like $100, but it would have been so cool for this stuff. I said shorty, I'm sorry. What the hell is that? This is a little hat. It switches to the falling edge of the clock. I see. Works. Okay, so it's on the falling edge of the clock, so it should be totally fine with the inverted signal. Well, maybe just cleaning up the setup that I had will get us there. So I'm going to do A first. A is pin 12. So 14, 13, 12. That goes to A. I'll need a slightly shorter jumper. Dang it. Dang it. Well, I can also just bend them. Just like that. Double check. 14, 13, 12. Yeah. So B goes to pin 9. And ground is 10. 9 is right next to it. So there's 9. I would like these to be straight over, but I guess beggars can't be choosers. C goes to pin 8, so it goes all the way over here. Oh, barely doesn't reach. There it goes. Okay. And then the last one here goes to D, so... Something's outside. Will's barking up a storm. As Hasanabe starts charging up his attack. All right, that's not as elegant. It's a little cleaner. Maybe I could use a longer wire here and it would be a little better, but this is like very easy wiring, so this is very easy stuff. This should go in clean. Why was that? So somewhere in between red and brown. Guess that'll do. All right, there. Much more. Oh, sorry, you guys had a bad camera angle on that. That is my bad. There. That's a little cleaner. So let's see what that does. Put in ground and power. Boop, 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 boop. Cool. Only one is lighting up. Oh, because these things are... I need to ground all of them. Oh boy. That's annoying. Well, I got jumpers for it. I guess I individually wired these instead of Goku Spirit Bomb, but it's to shock a dog. Oh god. I thought this would be cleaner. We don't do these things because we think they're easy. We do them because we thought they would be easier. That doesn't make any sense. Oh my god, she's really barking up a storm up there. Probably one of the neighbors that she knows walking by, because she loves barking like crazy at stuff and playing with her friends. So, and she has more friends than I do. There are people who are like, "It's Willow," and they'll like run up, and Willow's all happy, and I'm like, "Who the fuck are these people, Willow? Who are you? What the fuck?" They're like, "Willow, I owe you $40. Here's $40. I'm like, who, what? What? When did that happen? Oh, I heard them. It's one of the neighbors' kids who eggs on Willow. From the street, they will egg on Willow and get her to bark more and more at them. They're good kids, though. They're not being mean. They just like hyping up Willow. Okay, all 4 of those are now shorted to each other because I thought that this was a time-saving measure. Now I actually have to attach them to ground. Time to get out the hose. Get off my property. Okay, so it's still doing the stupid thing. Why is it skipping over like this? No, Willow's existence is entirely just to sit behind me on a bed because statistically, people will see the dog. I want to give more money to my stream. I bought her for that specific reason. So we are triggering on a low side, but it doesn't matter because clock edge is what this thing is looking for. On the outputs, and maybe the chip is bad, that could be a possibility. with two different sets of jumpers, this is the result we're getting. If I just test it using other signals, do those LEDs light up? Well, that was a partial confirm. Why did that light up suddenly? Huh? Huh? Oh, so it's the LEDs are bad. You were the chosen one. Ugh. So why are the LEDs bad? Why are you bad? Something physical. Yep, okay, so bad connection back here. What about you? Why is this one lighting up when I mess over here? They seem to be a little drunk, yeah. I don't know what the LEDs got into, but I don't know if I have this many LEDs hooked up in a sort of a lab setup. Oh, there's an entire missing... Is that supposed to be connected or no? Oh, they go back and forth. I see. I see, I see. Those all seem to be soldered in. I just don't know what's going on with this. It's so strange. Is it the breadboard? It appears as though it is counting. We just can't see these two. So if I could find a bunch of LED jumpers, then I can make up for this and not betray you guys and actually show you a working circuit today. Because it is counting, it's just not showing it. Let's see, over here. Perhaps. There should be a bunch of them, but they kind of wander around, so there's a chance that I don't... Yeah, I don't have any... I must have moved them somewhere, so where did I move them? Where could they have gone? There's this one here. Are there any in this? Not in here. That one is for that kind of circuit stuff, but nope, nothing in there. Okay. No, they're not backwards. I made that thing for... Jesus Christ, what was that? My light! I made this specifically for a bench setup, and I checked it over, so I don't think anything's backwards, per se, but, yeah, they're just dumb. I'm looking for wherever I stashed the other ones. There should be a bin in here maybe, or is it in, it might be in the thing, the part storage. That's a bin full of LEDs, but not quite the right thing. Let's see. I don't think this one has the LEDs in it, but it might. The sun fell down. Burning chat to a crisp. Whoa, that's a cramp. Good old diabetes. Can always rely on it to have my calf want to roll up like a window shade. God, those are so, they're so getting so strong as I get older. One day I'll be so powerful, I'll just roll up into a window shade in my entirety. There's a particular thing about glucose level and lactic acid building up that diabetics experience. I do have another LED board somewhere in here. There's a board that just has a bunch of surface mount LEDs on it. I like the one with the big LEDs, but I have one that has the other one. Man, I got all these accelerometers in here, and I bought more recently. Why do I have so many accelerometers? How many does a person need? I got to do something with all these accelerometers that I keep collecting. Maybe it's on one of the other boards. No, like I built this specifically. New manga hard type. Shuff, 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 shuff. Yeah, lactic acid also builds up when you do intense exercise. Yep. I used to be able to like sit out swim practice if I told them I got a little bit of a cramp. They're like, fine, get out of the water. I was faking it much of the time. I'm a very lazy individual. All right, so somewhere in this shop exists a little board that has a bunch of LEDs on it specifically for this purpose. And I built it for this purpose. Is it in any of the old breadboards? No, not on the old ones. It'd take me too long to set up a bunch of LEDs like this, and that's why I built that board. I just can't believe those center two are not working. I don't want to repair that. Let's see, where else would it be? Yeah, they don't want to take a risk with a kid drowning, with a diabetic kid drowning. Yeah, I don't know where those LEDs went. I mean, in your mind's eye, just imagine that those LEDs were counting up in sequence with one another. Because I cannot find a little board that I made that has a bunch of LEDs on it. And I can't figure out where I stashed all of those pre-made LEDs with resistors on them. Because I had a stash of those. I could have easily thrown 4 of them down. Rotate the apple in your mind. Do you see a drawing of an apple? Do you see a whole apple? Do you see part of an apple? I see me throwing an apple at you if you don't stop talking about apples. You keep talking about apples. Apple this, apple that. All right, let's see here. Yeah, I find that annoying that I can't find that stuff. I mean, there's a conspicuous absence of LEDs in this bin. They're conspicuously absent. I think that's my only dump. I need to make more, I guess. Need to make more. Put them in a specific location so that we can call them up when needed. I guess I can just plug in the LED that I have. Really, it would be 2 more I just need. I don't get why they're not in here. But they're not in here. They're not in here. They're conspicuously also absent from this one. This bin. A couple resistors down here. None of them on an LED. Nope. Oh, is that? Wait. No, that's not. There's like a little board with a bunch of surface mount LEDs on it, and I think it's in here. I think it's in here. I'm genuinely impressed by how organized you are. I need to do more. I need to do more organization. It's mostly a memory palace. It's a mind palace that I used in order to figure out where my stuff is in particular. Let's see, those are drivers. This is, aha, yes. Yes, good. These should be pulled down. Let's try it. Huh? Wait a minute. Well, how else am I supposed to hook this thing up? Are these supposed to pull up or down? Let's just take a close look. Sometimes I have to check my mouse or Amazon history to make sure I did buy something. That's a good way to do it though, because if you search your email, I think Google searches the PDF files, and so the PDF receipt from like DigiKey, etc., can all get searched. That's how I've done some stuff with like old DigiKey orders. Figure out what I need to buy. Ah. And they're not lighting up. Are these supposed to be pulled downs or ups? Because then I got to wire them differently. But these are all bussed together here. And then Dewey is the one who always can see where the anode and cathode are on these little ones. I can't. I'm not good at that. I see the wire going up this way, so these would want a ground. You don't hear it properly anymore because the internet ruined yet another word. I have to switch over to saying documents because TikTok didn't like a certain word. And so all the youth, language switches, they switch out a word. And we end up with really stupid slang. What a time to be alive. Okay, that isn't working, but if I invert it and we go to pull them down, they'll start lighting up. There we go. Still not operating correctly. Still not my tempo. So the lights being off should be counting up, and I don't know why it's not. It's doing a weird thing. Why is it operating like this? Do I need to be like flip it or something? So it wasn't my LEDs. It wasn't my LEDs. Things are, see, they're working. These are working, but they're not counting in any way. It should be, bits should be shifting in. Time for the O-scope. I don't know if the O-scope is going to give us too much insight into what's going on here. If I flip A and B, maybe? There's only one counter on this chip, though. Is there another pin that... Well, 74LS93, binary counter. That's what I'm looking up right here. And this would be the example circuit. It's just our clock A coming into pin 14 is inverted. That really shouldn't affect it that much. Holding down clock A doesn't do anything. It's just looking for an edge. So it being consistent should move through the counter until it reaches... I wonder if that is it. If it's my inverted, you know, seeking low thing here. If I could invert that, I don't know what the values of the components would be to invert it. Or if I put a hex inverter down on the board and then use that. Or just use a 100K and a transistor. Or a 50K and a transistor. Well, okay. All right. I'm out of time. I'm out of time. It's 5 o'clock. Sun's gone away. I need to give my dog a walk. She needs to get out there and see people that I don't know, and somehow they recognize her and I don't. Something weird is going on with this. We'll get to the bottom of it. I'm going to be back on Tuesday, and we'll work on this a little bit more. I want to fuse the music with the engineering and really teach you guys some stuff here and build something that's unique and interesting. We're getting there. It's just the initial growing pains of putting together a complex system, and that Moritz Klein video is amazing. You guys should definitely check it out if you've got many minutes to listen to some like deep, just sort of idea crafting and putting together. It's like, well, here we need this, and so we put one of these there, and it's really cool stuff. I would love to be able to work with this stuff faster. We do a variety of projects here, so I need to be kind of like ready for whatever's thrown at me. And so when it comes to breadboarding, I really should have all of this stuff. You saw, I remembered, I said I have a different setup of LEDs that I know works. Where did I put it? And it was where I thought it should be. I just didn't find it in time. Anyway, oh yeah, that's right. Maybe that's why I heard the kids, because it's Halloween. Happy Halloween, everybody. So I'm going to go out there with Willow, and it's going to be a spooky, spooky time. Have a good one. I will be back. Did I do the end card? It's probably going to say ago on it, right? And the stream will start in approximately 3 days, 20 hours, 36 minutes, and 7 seconds. I will see you all then. Thank you so much for joining me. And we'll do cool stuff soon. I'll make sure we can make some drum noises or something. And I will catch y'all later. That's not my catchphrase. Do you have a cat? Do I have it? Do I need a cat?